Hello everyone. Here we are back with a new episode of System Design in Depth. And in this episode, we're actually going to design a stockbroker. In the last episode, we have designed stock exchange. You can take a look at that previous video. So we are going to build on top of that today. That how we are actually going to use that stock exchange and build a stockbroker on top of that. So Karthik, let's start. Yeah, so
So,
let's design a stockbroker where something like Zerodha, right? Or Robinhood, where we'll be managing the portfolio of different users. Yeah, portfolio of
so the
yeah,
first requirement is basically this broker should be able to manage the portfolio of user.
yeah,
Manage users portfolio.
yeah. Manage user orders, so I can
So
buy something or
portfolio
sell
is
something.
basically portfolio is basically how many stocks or how many units I have bought for a particular company,
Yeah,
and
it's a sim.
I,
It's it's a symbol of the stock. At what price you bought, bro? You bought the stock. How many
Mhm.
quantities, and what is the current price, and what is the current ticker price of that stock? Something like that. Yeah.
Yeah. Second requirement is basically
User should be able to execute orders. So orders is like
yes.
whenever you sell or buy, immediately you see a page coming up, right? That the orders which are currently in progress, which are not settled yet. Yeah. So once the orders are settled, they go to portfolio. There are no more orders. They directly become part of your portfolio. Yeah.
Yeah.
And stock ticker. So you should be able to relay the value of the stock tickers to the users. So maybe users can have watch list, or maybe users can have some level of subscription, whether they are through watch list or they are through portfolio. So those stock tickers should be streamed to the user.
Yeah. So basically, user will be able to create a watch list, and
Yeah,
they have the portfolio as well, and for both we will be showing the current price.
true, true. As much as near real time possible. And
Okay.
maybe the final requirement is like wallet management. So the stockbroker should be able to take money from your bank account and
Mhm.
store it to itself, so that the stock clearance house can uh, talk to this wallet or talk to the stockbroker, take money from this wallet and put it to the sellers or buyers, whatever sellers wallet.
Okay, and we can assume that for each of the orders, user would be paying from their wallet. So
Yeah,
if user has to execute an order, if user wants to place an order, then they should have some money in their wallet.
yeah, yeah, true.
Any other function requirement?
Now let's keep it to this four. Should be enough for now.
Okay, so let's talk about non-functional then. So in
Mhm.
non-functional, let's first talk about the scale that we are targeting. So um, so if we just talk about India, then India has basically two stock exchanges, and both of them have approximately 10,000 companies registered. I think I think one of them has 4,000 and the other one has 10,000, but we can assume that in total we have 20,000 companies. So, or 20,000 symbols.
Mhm.
That is one thing. And
So
apart from that,
essentially you mean that your broker can the broker can be integrated to multiple exchanges.
yeah. So broker can
Mhm.
integrate to multiple exchanges, and
That makes
uh,
sense.
even if a company is basically registered on two separate stock exchanges, we
Mm,
will consider both of them as separate companies so that
mm,
it's easier to maintain.
okay.
And the symbol allotted to them will also be different.
Mm.
So yeah, so we have 20,000 companies, and then number of users. Uh, so number of users we can maybe think of. Uh,
Yeah, let's say we have 20 million total users on this system. 100 million is too much, man. I'm not sure. I don't know the data actually. How much is the total user? I'm just assuming that 20 million active users might be there monthly, and maybe
yeah,
around five, and maybe around
I think
5
for
million
Zerodha
daily.
it's 20 million. Yeah.
Yeah.
Number of orders. So 20 million on average, one person executes. I mean, it also depends on what kind of trader that particular person is. So the intraday trader might be placing more number of orders than I would
Yeah.
say other kind of traders. But maybe we can assume that on average, one user places 10 orders per day.
Okay.
10 orders per day per user.
Okay. Okay. So just to clarify, so are you taking 20 million users daily?
We can assume that all of them are active. So we can assume that
Okay.
they are, I
Okay.
mean, daily active
Mm.
users.
Okay.
So in total, this comes to around I would say 200 million orders per day. Okay. So this is a good enough scale, I think. So let's go ahead.
So what is
So
the
we
Q,
have talked.
what would be
Sorry.
the QPS? What would be the QPS?
So QPS for yeah, I think there are two kind of QPS that we have to think about. One is uh, the kind of read QPS. So read
Mm.
QPS is basically uh, you know user wants to see the current price of for a particular stock in their watch list or portfolio. So that is one kind of QPS, and the other is basically the number of the orders being placed. So for orders, it would be 200 million, which is basically 200. It's basically 2 into 10 to the power 8. Divide by, we can assume we have 10 to the power 5 seconds in a day. So which comes to approximately
2000.
1000 QPS.
Okay.
So we have a QPS of 2000
Mm.
for just for the orders, and for the read part, actually, read part. I mean, let's say,
Yeah.
so that is actually a little difficult to talk about right now, because that will also depend on what approach we are going to take later. Because let's say if we just take polling, so let's say if I have Zerodha app or any other app on my device, and that app actually polls Zerodha's backend to get the current stock data. So if we basically take that approach, then the amount of read QPS coming to Zerodha's backend would be lot. I mean, for 20 million users. But if we were to take any other approach, for example, let's say server sent events or something like that, then the QPS would not be. I mean, it's basically not the read QPS. It's a different kind of scale. So basically, we all we have to do is we need to basically manage these number of connections. Then,
So
so if
so
we have
hold on.
20 million,
Yeah.
then 20 million connections.
Yeah. Irrespective of that, I think let's say when you open the app, what do you see first of all? Mostly you navigate to the portfolio page, right? So the
Yeah,
details of the portfolio. So one thing is that uh, that's most likely probably at a high level in API call, the portfolio, right? So if you log in 10 times a day as a general user, maybe some trader might be logging in probably 20 times a day, or he's probably logged in the whole day, something like that, right? So that will also be part of the read. Forget about streaming the data. I'm just saying, even just seeing the portfolio or seeing the watch list, that's
Mhm.
most likely an API call, isn't it?
Yeah, so normally what happens is, I mean, even for streaming kind of connections, I mean, we don't really use the WebSocket. We actually, so I'll take an example of, let's say, LinkedIn's messaging. So in LinkedIn's messaging, if you were to see the online offline status, that is actually sent through server center connections,
Hmm.
server sentiments. But let's say if you want to send a message, then that is just a simple REST call.
Yeah.
So it's basically a mixture of REST plus SSE in most cases. So
I
there
mean,
will
just
be
to
many
simplify it,
calls for,
yeah,
yeah.
yeah, just to simplify it, right? Let's not probably think about the streaming right now because that architecture is not clear right now unless and until we build the system. Purely from portfolio perspective and watch list perspective, what do you think? What will be the read QPS? I mean, we can
Uh,
simply build on this QPS, right? I mean, the write QPS is like 2000 QPS orders. So read
mhm.
might be 5 times more than that. No, something like that. Does it make sense in terms of just fetching the portfolio and fetching the watch list?
Yeah, I mean, so I think there are very few systems where, read QPS is lesser than the write QPS. So we can actually, so read is always, multiple of write QPS anyway. So
Yeah,
whatever, system we come to build later, I mean, the read QPS would be multiples of write QPS. So yeah, I think we
yeah,
can take that basically. I mean, the number might not be correct, but yeah,
yeah,
let's go ahead with
yeah,
some
yeah.
rough.
Even I'm not sure about the real numbers, but I'm just saying that it could be. Let's assume that it's something like 5 times the orders. Uh,
Yeah, so let's take 10,000 QPS.
okay.
Okay.
Yeah.
Now, talking about, let's say, cap theorem. So, what kind of consistency do we want? So, one consistency that I can think of is, uh, I have money that is deducted from my wallet,
Yeah.
but maybe the order was not placed. So, those
Yeah.
kind of consistency problems should not happen.
Yeah.
So let's say if order was, I mean, if we couldn't place the order due to some technical issue on our end, then the payment will should also roll back.
Yeah.
Uh,
True.
of course, I mean it can be done later in the reconciliation, but we'll try to ensure that it happens immediately. So that is one thing, and
Yeah, I
what
think
else?
just 1 second. You came up with a good point of reconciliation. Do you think it should be part of functional requirement? That we should have some kind of reconciler.
I mean,
Uh,
wherever money is involved, I mean, we do have reconciliation service. So maybe let's put that into good to have.
yeah.
So reconciliation service.
Yeah. Okay. Yeah. So I think one more thing from non-functional point of, so here consistency applies in fraction, not to the whole system. Because if you put some inconsistent stock ticker value, unless and until it's very old, it doesn't matter.
Yeah,
Right? So
yeah.
we don't need consistency in stock ticking. I think one more important thing is that security of the system, right? Uh, are we applying any kind of encryption, decryption, or compression to the data or anything like that?
Yeah. So yes, consistency in order placement. Then of course we need availability. Then security you talked about. So what can we do in security? So one aspect of security is basically, let's say I'm a bad user and I'm able to place an order without having money in my account. those kind of things. So I'm able to buy an order without paying anything. So that could be one part of one aspect of the security. Other I mean, there can be other things like DDoS and all, but maybe they're sort of out of scope. uh,
I mean, let's keep it simple. So I think you need to have the wallet balance. So that wallet is completely managed by the broker.
mhm.
So unless and until you put some money into that balance, into that wallet, you won't be able to buy any stock at all. So uh, I mean, is it possible that someone can manipulate their wallet? Is it even being possible? Because it's not, I mean, it's not a data that you are transferring from the client side while putting the order.
Mhm.
You should not put any money amount while putting the order, right from the client side. The server can do it basically. When the server may be talking to the exchange, it can do it, but you can't. So probably that is out of scope that without any fund you are buying, right? I think that is probably out of scope. But we should be able to somehow encrypt the data so that no one can sneak into the data from technical side. And
so I mean, yeah, we can do that, but it's more like a very general thing to do in kind of all systems. So we can have sort of ACL management system that the database is does not I mean, only one service has the right access to this particular database. And there can be other services which are read access to this database. uh, those kind of things, yeah, but I think they are very generic kind of things, so they are mostly available in all kind of systems. But yeah, we can basically talk about them if we have time. So I'll
I
keep
think
it
in the
overhead,
last in the last design exchange, we actually talked about placing big orders.
Mhm.
So uh, probably, do you think the same kind of checks can be here in the broker side also? That the broker checks if you are placing very high orders, so that even before going to the exchange, the broker can actually reject the orders.
So that also comes under I mean, basic rate limiting. So rate
No, no,
limiting is
no, no,
something
not
which is
not
basically.
rate limiting. I'm talking about the volume of the orders. Let's say that you want to buy some stock, but the volume
Mhm.
is 100K, 100K. So that's not rate limiting, right? I mean, you want to buy stock of, let's say, Reliance, and you want to buy stock of 100,000. I mean, 100,000 is the quantity. Should the broker allow you buying of 100,000 Reliance stocks? So that's a basic security check, right?
uh, I mean, we can actually put that in a sort of validation, probably uh, not in security, I would say.
Yeah, that's more of like a security requirement, I think. Uh, I mean, security in the sense of the business security, right? Security from from the sense of like, how do you make sure that uh, reduce the abuse of the system? Um, so that's one thing. I mean, whether you put it into validation or gateway or some layer, that's up to your design. But more from business perspective, I'm saying whether does it make sense to include that those
Yeah,
kind of
we can put
checks.
all these things. Yeah. So let me just put checks and balances. I mean, balance will not be a good keyword here. Okay, so we have talked
Yeah,
about security
maybe
and
maybe one more security option could be like we have PAN number in India or maybe in
Mhm.
other country, TAN number or something like that. So can a single person create multiple accounts with the same PAN number? Do we allow this? So that's also part of security. I mean, you are not allowing. the same person to have multiple accounts actually.
So I mean, do we want to put the pan check here as well?
Yeah, I think, I mean, I'm just trying to think with you. Does it make sense to put the checks as a part of security? That
So
uh,
I mean, we can actually think of a lot of things, but I feel these are actually very low level things. So in real life, there will be, a lot more things rather than, having just these. So that's why I didn't want to
mhm,
go
okay,
deep into these things.
okay, okay.
So another important aspect is basically latency.
Mhm,
So the orders should be executed very fast because especially for intraday orders, this could be a sensitive thing, I would say. So that's why things like co-location and all those kind of things were, exist. So latency is very important in our case. So we'll try to make the whole system as fast as possible in terms of latency.
mhm.
What else?
Yeah. Uh, Throughput.
Throughput will come under scale, right? Or any
Yeah,
other.
I think that is the I think I thought like there is a scale requirement that you wrote here, but yeah, that eventually translates into high throughput system in terms of read and write. Yeah, the system should be high throughput. Yeah, latency, security, availability, consistency, scale. Yeah. Yeah, I think this much looks good. If we find something else, we'll write it down later on. But I think there are too many requirements anyway right now. Yeah. You have anything in mind?
So there is one more thing actually. I think so. We need to try to build our broker in such a way that it puts as less load on the exchange as possible. So it shouldn't really put a lot of load on the exchange. So let's say if exchange provides an API for the ticker, so we shouldn't just bombard exchange API to get the ticker's latest price.
Hmm.
So we will have to. That is one consideration basically that we can
But I
keep.
think that will largely come under the latency umbrella, right? The latency thing. I mean, the latency could be end-to-end latency also. The latency could be stock tickers latency also, right? I mean, I'm assuming like that. That when you say latency, you mean that the order execution should be faster and the ticking should be faster as much as possible.
Yeah,
Yeah, so
yeah.
that should be covered by
From end
latency. Yeah,
user's perspective. Yeah.
yeah.
So user, if the price of stock changes, then user should get the updated price as soon as possible,
Yeah, true.
so
Yeah,
that user can make a decision that
yeah,
to sell or buy.
true.
Okay. So we have talked about these things. Let's talk about a high level design. So we have a user, and this user connects to, let's say, some service. So for, the requirements that we have is basically we need to manage users portfolio. So user, I'm assuming that user comes to broker's app. User places some order, and if that order is successful, then whatever was the outcome of that order, that is reflected in user's portfolio. So That is one thing. And when the user lands on the app, user should be able to see their portfolio. So maybe we can start with a portfolio service directly then. So let's say we have a basic
Okay.
portfolio service.
Hmm.
And whenever user wants to see their portfolio, basically they make a REST call to this portfolio service.
Hmm.
So I mean, first time user lands on the app. At that time, we will be making a call to portfolio service to fetch the portfolio. Then
Hmm.
so portfolio service, of course, portfolio service would be managing this data in some database.
Hmm.
So we have portfolio database, let's call it portfolio database. So now, if you talk about the technology of portfolio database, I think we can keep the technology part for later because I think we
Yeah,
will
yeah,
cover
yeah. I think
basically
let's
everything.
complete the high level design of the whole system, and then you can deep dive. Yeah.
So that basically was this part, and now users should be able to execute orders. So let's say we have an order service, and if user wants to place an order, then user basically makes a call to the order service. Now
Okay.
order service, uh, so there are two kind of orders basically. One which were placed but they were not executed, so they were not successful, and the other were which were basically successful. So we need to store both of them anyway, irrespective of whether they were executed
What
successfully or not.
what do you mean by successful? I mean somehow the matching did not happen. Do you mean by that?
Yeah, yeah. So let's say
Okay.
if I want to buy a particular stock of, let's
Hmm.
say, Microsoft, and at a particular price, I sent the order, but it could not be executed. So that was a failed order. So failed orders also we will manage. I mean, we will store. Um, so we have an order database.
So
So order.
what could be the
Yeah.
possible reason for failure? I mean, one thing I can think of is probably you don't have enough balance, but you tried to execute the order and the exchange rejected it. Or maybe the broker app itself rejected it before going to the exchange. I don't know who does it in real life, but this is one failure case. Other failure case might be the exchange somehow for other reason failed to execute. But any idea what could be the possible cases of exchange failure?
Um, from the exchange, I mean, earlier we had when we had talked about the exchange design. At that time, we had uh, discussed multiple failure scenarios. So one of them was basically user doesn't have enough balance in their account. So from broker, we will not be sending those orders to the exchange anyway. So that part is ruled out. The other were some other were some kind of orders which were violating some rule. For example, as we earlier talked about, let's say there is very large order and you may be uh, I mean, let's say, I mean, so what happens is, so there are actually, you need to be a certain kind of, what do we call it, FII. So, not
Yeah, I
FII,
mean,
actually, institutional
dep
investor. Yeah. If you
yeah,
want to place orders.
depending on the investor's type, there can be different kind of order execution. But I think I'm talking from more technical perspective here. It might also happen, right, that the exchange doesn't have the right allotment or right amount of stocks to actually match. I haven't seen this case really happening, but that also can be technically possible. While matching, you have buy request, but the order is so popular, the symbol is so popular that there is no more allotment there, right? So
Yeah,
that
so
can be
the
also
order
possible
could not be
case.
matched. Yeah.
Okay. Okay. Okay, anyway, let's move on to the next part here.
So
So,
now,
yeah,
of course, we also need to send that order to the
exchange.
exchange.
Yeah,
So let me just is happening. Okay, and maybe let's call it exchange.
okay.
So the order was sent to the exchange, and maybe in parallel or before sending to the exchange, we had basically put the order in the database. So this is something that we can talk about later.
Yeah,
Now, we need a stock. So we also need a watch list or stock ticker. Then we also
yeah.
have a wallet management. So let's build a service for a wallet first. So
Why is this arrow coming here?
no idea.
You can undo it, right? Just undo it or delete it.
Trying to undo what?
Yeah, just click on this and click delete. Yeah, yeah.
Okay, so basically, wallet service, I'm assuming it's just for the read part of the. Yeah, I mean, this is just for the read part, maybe we can say. For actually, loading the money in the wallet, maybe we can have separate service. Maybe we can call it a payment service.
Mhm.
So, or maybe we can just combine them, both of them into same thing.
I think you're referring to adding fund. Yeah.
So to check the wallet balance, so let's say if a user wants to check their wallet balance, the call from user will come to the wallet service.
Mm.
For the payment part, we will actually create a separate service. So payment actually means that user pays money. I mean, user basically pays money, and then that money basically gets added to their wallet. So let's call it payment service. So payment service is the one which will have the whole front end for showing all the payment options, and then processing the payment maybe with the backend of payment gateway, those kind of things. That all thing will be happening at the payment service.
Yeah.
And wallet service is basically a simple service which in a way is just displaying a number, or just dealing with a number. That number is basically the user's wallet balance.
So
So of course,
I understand the philosophy behind multiple services that we are using here, but can they be combined? I mean, uh, even though the modules will be different inside, the wallet modules and payment modules will be different inside, but can they be part of the same service because they are anyway very lightweight?
we can do that actually. So that I mean, that anyway actually depends on how much. So of course it's possible. I mean, you can just create one big monolith and put all of them in one service.
Okay.
But in reality, at some point you would want to create teams for particular services, for particular, let's say, functionalities of the system. For, let's say, I have one team for which manages the portfolio part, and the other team manages the order part.
Hmm.
So if those teams actually want to work on their separate things, then you would want to move towards microservice
Yeah,
based
yeah.
architecture.
Yeah, I understand that. I'm just saying that since both are lightweight right now, so you can probably put them in the same service. But yeah, as they can exist as a different modules. Yeah, okay.
So wallet service basically talks to the wallet database to
Mhm.
uh, fetch the data from the wallet database, or maybe if you want to. So if a user wants to add money into their account, then user will go to payment service. There they'll do the payment and all, and the side effect of that would be uh, adding the balance into user's wallet. Of course, this part
I
is
think
actually not
it's
simple. Yeah.
I think it's better
So
to give wallet this responsibility actually. I mean, a wallet service can have APIs where user can add fund, and the wallet service can internally talk to payment service to actually facilitate that.
uh, you mean if a user wants to make a payment, then wallet service provides the API for choosing the payment gateway, payment options.
Yeah, I mean, all I'm just saying is that once you try to add fund, click on the add fund button, you are redirected to the payment page, right?
Mhm.
So the add fund is essentially calling some API behind, which is powered by wallet service. And
Yeah.
once you go to the payment option page, right, then probably the interaction can happen through payment service, right? I mean, which
Yeah.
bank to basically choose. But I think don't you think so? Those okay, are those offered by payment service or are those offered by third party like Razorpay and stuff like that? Uh, I think in at least in Zerodha, you have option to choose which bank and something like that, and then it goes to uh, the payment service, Razorpay like service. Yeah, so I think you are correct that the ad fund can be facilitated by the wallet, and once you are into the uh, middle page, it can actually show you the banks that you have SBI, you have HDFC option, or you have UPI and those kind of things. And once you click on one of them, maybe it redirects to the third party payment service like Razorpay or BillDesk to actually do the payment.
Yeah. So in reality, what will happen is, I mean, we also need to provide things like idempotency and all. So let's say if a user has made payment for let's say 200 rupees, then only 200 rupees should be added to user's wallet. I mean, it shouldn't be like 200 was added twice. So to prevent those kind of things, what I mean, we will be providing idempotency.
Mhm.
So in order to do that, we will actually be starting the flow at the wallet service only. So user comes to the wallet service, user when clicks the button on add 200 rupees to wallet, the request comes to wallet service now generates a unique ID, which will basically work as the idempotency key. So maybe we can call it the transaction ID or something like that, and then we use that key to to basically ensure idempotency in our whole system. So that key will be provided to the browser, and then user, I mean, basically user will be redirected from the wallet service to the payment service. So we will be basically passing that key somewhere in the URL or something like that, or maybe we return the response to user, and from there that basically gets used. So and then payment service basically so what happens is when you are so in order to make the payment, you will be integrated to the payment gateway. Payment
Mhm.
gateways also require some sort of idempotency key, so that
Mhm.
the idempotency can be maintained. So this key we can use as the idempotency key in case of payment gateways as well. So what will happen is user makes a call to the payment service.
Yeah.
Payment service makes a call to the payment gateway. So payment gateways, maybe SDK is initialized, and then the whole process, the whole flow completes on the payment gateways end. Then payment gateway sends a response to the payment service that the
Hmm.
transaction has completed
Yeah.
for this particular idempotency key. Then gateway service, payment service will call the wallet service to add the money into the wallet. And for that transaction as well, we will be passing this idempotency key in the transaction as well. So in short, the idempotency key is very important, and the flow will basically start at the wallet service. And this is roughly how the things, I mean, how the services and all will be involved.
Okay,
So
can you put the third party payment gateway also in this picture?
yeah, so maybe let me put it here.
Yeah, so this is whole one single transaction. And
I mean, this cannot be done in one transaction because there is third party involved and there are different services involved, and user is also in a way involved. So I mean, in strict technical sense, it's not a single transaction, but from business perspective, we can call it transaction. So yeah, it's basically
okay, okay, try to we'll probably try to dig deeper into this, that how to handle the consistency in this flow. But yeah,
yeah.
let's go ahead with the other part of the high level design.
So we have talked about we still haven't talked about the stock picker, watch
Mm.
list, and portfolio. So portfolio we have maintained here. We will also need one more service.
Yeah, I think a watch list can be maintained in the portfolios service itself.
Uh, yeah, I think in a sense they are same things, uh, except for the part that the portfolio is basically edited when the order is also made. Apart from
So
that,
your so your watch
basically
list
user.
is yeah, your watch list
Yeah.
is basically kind of static. I mean, you can add
Mhm.
more and more items to the watch list, and but everything has one thing common, that even if your portfolio, your watch list have common stock ticker, right?
Yeah.
So yeah, in a way, watch list and portfolio are kind of similar. Just that portfolio is only, I mean, portfolio is the actual value of your assets, and watch list is not. That's it.
Yeah. So we can actually manage them inside the portfolio database. I think initially we can just go ahead, with managing them inside the same database. But let's say later, if I mean, it happens that the system evolves and there is complex logic, which is basically has developed in both of them things. Maybe we can separate them out. For now,
Mhm.
we can go ahead with same database,
Okay.
portfolio database. So here also, let me just write
Yeah.
watch list as well.
Mhm.
So if user wants to, see their watch list, they will basically make a REST call to the portfolio service and they can see their watch list. So here what will happen is basically we will have two separate tables here. One will be for portfolio and the other would be for watch list. Uh,
Mhm.
yeah. So
Okay.
now the thing is ticker part. So
Yeah.
watch list user is able to see, but user should also see the price of a particular stock in the real time. So we need a sort of trigger service. So let's assume that
Mhm.
user makes a user basically polls this ticker service to get the latest price. Of course, that can be one way. Simplicity, I mean, for simplicity, we just let's say just assume that user makes a call to the ticker service for a particular stock, that what is the current price for this particular stock. and ticker
Mm-hmm.
service basically responds with the current price. So for simplicity, we can basically assume that. Of course, uh, in reality, the system would look much different, that we will basically talk about in the deep dive. But for now, let's assume that. And we also need a sort of ticker database. So ticker database. So what do we need from the ticker database? That is one thing. So that's when, I mean, by that we can basically talk about the technology. So ticker is, what is ticker? Ticker is actually the current price of a particular stock.
Yeah,
So do we need to maintain the history of the prices for a particular stock? I don't think so. So in
you
case
don't need
of
to.
brokers, I don't think that is important.
Yeah,
So
it's more of like a
uh,
very transient data.
yeah, it's very transient data.
Yeah,
Uh, it's a transient data that gets written very heavily, and
even if you
I
lose
mean,
it, you can, you are always getting
even
it
if
from the
we
exchange
lose
anyway.
it, then yeah, we can
It's not a
just call
problem.
Exchange API to get the data.
Mm.
So rather than using storing, and then there is one more thing. So we should be able to read this data very quickly. So we
Mm.
have basically talked about three use cases, and all three use cases basically points toward one. I mean, the thing that we don't really need a database here. So what we need
Yeah,
instead need is, we need a cache.
yeah.
So we can have cache. So basically, ticket service, what it does it, then user makes a call to the ticket service. Ticket service actually fetches the data from the ticker cache and then displays to the user.
Mm.
Now, of course, ticker service also needs this data. So ticker service will be needing getting this data from exchange. So for now, let's assume that ticker service also makes a REST API call to the exchange to actually
Mm-hmm.
fetch the current price.
Mm-hmm.
Let me just call it exchange. Okay. So I think we have most covered most of the things in very high level. We haven't talked about reconciliation. So do you want me to, maybe talk about reconciliation in brief, or should we just jump into details?
Yeah, I think one thing is reconciliation at a high level. Another thing is the clearing system, right? Uh,
Mhm. Yeah.
the clearing house, whom it is going to talk to here.
I think clearing is something that can be complicated. Uh, I honestly don't know how clearing actually works. I mean, do they clear the settlement at the end of day, or how does it work? So, I mean, if they are clearing the settlement, then they also need to, send some data to us. So, how do they send the data? I mean, there can be different ways to, send the data, but I mean,
No,
we
I
can
think,
basically make some assumptions here and then maybe, talk about how to build a system to incorporate those assumptions.
yeah, I think
What do you think?
one thing is clearing definitely. I mean, since the broker itself is managing fund and wallets,
Hmm.
and it has essentially it has the money, right? The
Yeah.
money is just not transferred to the seller or the buyer, basically the seller
Yes.
essentially, right? So you have the buyer's money as a broker, but you have not transferred it. So we can, for now, we can assume that the clearance house is actually talking to this broker through some APIs and getting all the clearance information from for today and transferring it in some way to the seller. So yeah, so I mean essentially nothing but we should have an API through which uh, every broker can actually tell the clearance house that this is the clearance data for today, right? And eventually
Ye-
leave it on the clearance house how it actually does or how it actually transfers money to the seller. So we can just have that box that clearance house will be there and it will be talking to our maybe our order service, right? through some API. That's one option. And
Yeah,
also,
so
yeah,
actually, we can actually talk about a lot of things on even on that end actually. So I mean, so what happens is, let's take an example of a food delivery company. So food delivery company, takes the money from the users, and food delivery company has to, settle those amounts with the restaurant, because ultimately it's mostly, restaurants money. So what food delivery company does is, it basically calculates the total payment for for a particular restaurant, and in the backend it also has a bank account of that particular restaurant, and at some intervals, maybe let's say after 2 weeks, or maybe every night, it actually makes a call to bank's API to transfer the money from food delivery company's account to restaurant's account. So it's actually making a call of bank's API, making a call to the bank's API,
yeah,
and they're basically providing the account number.
yeah. I
So I
mean,
think
that's pretty much the case at a high level for if you manage the system. But honestly, even I don't know how clearing service works. I think it should be having some kind of standard mechanism so that you can transfer the fund. But we are not much interested into how clearing service does that. We are mostly interested in that how clearing service is actually talking to this order service. So maybe we can just put a box for clearing service, and it can talk to the order service through some specialized format in API. Or maybe the order service needs to implement some specific API, as instructed by the RBI or any other thing, which can be called by clearance service, something like that, or SEBI, which can be called by clearance service. So you can just put that box.
so. Yeah, I
Yeah.
mean, it's very unlikely that clearance service will call our our API to initiate the clearance. So it will be most likely a push based system, where our system actually makes a call to their system to basically do the clearance or something like that. So we can
Mm.
actually do it maybe at the end of the day, or we
Okay.
can do it after every single order. So after every order, we basically make a call to their API, and maybe
No, I think that will be
uh,
pretty high, right? Usually, if you see the stock exchange systems, I mean, in the stock systems,
yeah,
settlement is done on a daily basis, T plus one or T plus two, something like that, right? So it's not
yeah,
instantaneous, rather it's done within 24 hours to 48 hours time, mostly, if I'm not wrong, right?
yeah. It's T+2. Yeah.
Yeah, so we can put that thing here. Also, one more thing is like the stockbroker has to report the transactions done by the users to the depository, right? Essentially, the electronic demat will be the source of truth for any user's portfolio, you can say.
So
So,
that can actually be done by the stock exchange as well. Maybe the broker doesn't have to do that.
so, in reality, I don't know who actually does this, but it's much likely that once the settlement is done, it is initiated by the broker because
Yeah, settlement will be.
exchange in our
Yeah,
case, we have assumed that exchange is the matcher. So it already does the heavy lifting of matching things and security checking and stuff like that. And it's the broker who will actually immediately get to know when the settlement happens, whether it initiates the settlement or clearance house initiates the settlement. Irrespective of that, it knows when the settlement happens. And at that point in time, it can probably put the data to the depository that, hey, these are the transactions, right? Add this to the portfolio of this user. So that is kind of the source of truth. Just in case this broker goes out of business, another broker can come and fetch this demat account from that source of truth. I mean, that's how likely I think. Even I'm not sure how exactly it works. I've never developed this kind of systems. So,
yeah. So basically, if you think about it, let's say if Zerodha failed to make a payment for, let's say, 5 days.
Mm,
So ideally, exchange should block all their transactions or their all their new transactions. So for that, exchange should also know that they have exchange or the clearing house. They should know that for all the orders they have made the payment. So let's say if we have a third party in between, let's say some sort
mm,
of payment gateway, so
mm,
exchange can actually make a call to payment gateway that transfer this much money for these orders from my account to, let's say, clearing house's account. Once payment gateway does that, then payment gateway will send a will notify the clearing house through their webhook that this much money was transferred for these many orders from this broker. So since it's a uh, webhook on clearing houses end, so they can basically process the data on their end for those particular orders, that for these orders the amount has been successfully transferred to our account, so there is nothing due on Zerodha's end. So that can be one way, but yeah, in
I
reality,
think
I'm pretty
let's,
sure that the system would be really complex.
I mean, let's keep it simple for our use case. I mean,
Yeah.
uh, somebody has to know the source of truth, all right? Somebody has to be the source of truth and somebody has to initiate the payment. Now, whether that should be the broker, I don't think the exchange does it. I'm not sure. Why should exchange do it, man? Uh,
Yeah, I mean, if exchange does it, then it would be a sort of pull-based approach. So the problem with pull-based approach is that, what if the broker is not able to respond at that particular time? So then it will have to, try again after some time. So I have seen that, most of these kind of settlement systems, they work on the push-based approach only. So they can actually, do the settlement within a particular time whenever they want to do it. So within T plus
yeah,
two, whenever they want to do it, they can do it.
yeah. I think instead of exchange coming into picture here, I mean, the broker can initiate this with the clearance house that, hey, I have these transactions for today and, to clear this settlement or push for settlement. And the clearance house can take it at its own pace. And once the broker knows that the settlement has been done, then maybe it can put this portfolio, the new orders to the demat account or to the depository, right? Or it can put to the depository once the order has been placed, but with a state like placed or something like that. And once the settlement has been done, it can confirm back to the depository that, hey, it is confirmed, the orders are confirmed, right? Something like that.
Yeah.
So yeah, I think let's assume that the broker initiates because it is legally bound to initiate all these transactions. And if it doesn't initiate, there might be some legal actions and whatnot. That's a different thing. So can you put these boxes for these two things, depository and clearance?
Okay. We didn't talk about reconciliation, so maybe I'll take maybe 2-3 minutes to talk about reconciliation. So
Mm.
in our case, the scope of reconciliation is basically, let's say money was deducted from my wallet, but the order was not placed. Something happened. I mean, in the deep dive, we will try to make sure that that doesn't happen. But let's say if it does happen, maybe due to our approach or something like that, then what happens is, I mean, the wallet money was deducted from the wallet, but the order could not be placed.
Yeah.
So for that, what we will do is basically we will do the reconciliation. So what is reconciliation? So reconciliation is nothing. It's basically a sort of at the end of day job or something like that, that basically corrects the inconsistencies in our system. So
Mhm.
we will have a, I mean, it doesn't have to be a cron job, it could be anything, but let's assume that we have a cron job that runs at the end of day. It basically, reads the data. It will read the data from the wallet database, and it will also read the data from the order database. It will compare the data from both of the databases, and it will see that, for this particular transaction the money was deducted from the wallet of this particular user, but I cannot find any order for this particular transaction ID. So maybe, joining both these two tables. So I mean, by doing that, it can identify that, for this particular transaction, this is the transaction for which, there is inconsistency in our system. So what should we do in that case? So we should, return this money to user's wallet. So what it will do is basically it will initiate a transaction. I mean, it will initiate a refund transaction. So that refund transaction will actually transfer the money from broker's account to user's wallet. So this whole process is basically called reconciliation. So maybe let me just put
Mhm.
a box for reconciliation service here.
Put it between this order database and wallet database. Can I put the arrow from reconciliation service to both the services? Both these two, yeah.
And of course, it has to make, it might have to, initiate the refund transactions. For that, it will be calling the wallet service. So of course,
So this
scaling this
is
part is another thing. So, but yeah, let's maybe not talk about that, because, these queries are very huge queries which will be running on these databases. So I mean, we can basically probably cover that part in a separate problem. For now, we
yeah.
can skip this.
Yeah, we'll see if we get some time in deep dive anyway. Yeah. So okay. So
So I
we have
think we have mostly covered the function requirements. So now let's deep dive. So let's start with let's just start with the ticker. So in ticker, we
Mhm.
will be talking about how the user is connected to the ticker service, and how the ticker service is getting the data from the exchange.
Mhm.
So we will talk about these two things.
Mhm.
So first thing is, how the user should be connected. I mean, one thing is basically user makes a call, makes user basically polls the current price for a particular stock at every few seconds. So now, what is this number? What could be this number? Should it be 1 second, 5 second, 10 second? So the answer is we don't know actually. So the price can change at any moment, and it's completely up to us, how fast we want to make it. So let's say if we want to make it very fast, very, fast in the sense that, the price changed at exchange at, let's say, 12 o'clock. So by 12 o'clock, 100 milliseconds later, the price should be reflected in our system. If we want to build that kind of system, which is basic, I mean, where the price is reflected in our system very quickly. So then the I mean, not in our system, basically in basically user's app. So the price is, basically propagated to the user very quickly. So if we want to do that, then we need to, increase the polling frequency. So rather than, let's say polling at every 1 second, we should be polling at, let's say, every 100 milliseconds or 50 milliseconds. So of
Won't
course,
that be
if
too much of
yeah,
polling?
if 20 million users were to do that, then that is huge read traffic on our system. So, and read traffic is one thing. I mean, most of these calls will be wasted anyway, because
Mhm.
there would be certain stocks for which the price doesn't change much. So what do we do that in that case? So we need a system where we need a sort of connection protocol which can uh, provide the data to the user as soon as possible. I mean, as soon as the ticker service has this data, it basically sends this data to the user, or as soon as the exchange has this data, it actually sends that data to the ticker service.
True, correct.
So now, what should we use on the user and ticker service end? So of course,
So, so are there, since it's a financial system, do you know of any real life protocols or anything like that that actually is used?
so I mean, I was about to cover that in the exchange to ticker service part. So
Okay,
let me
okay,
just
okay. You
talk
can
about
cover this.
first user to ticker service part. So
Okay.
user to ticker service part, of course, we need. I mean, the problem that I talked about. I mean, there can be two ways to solve that. One is we create a WebSocket connection. So there is socket connection between the user and the ticker service. And so what happens is basically, as soon as ticker service has the latest price, it actually sends the message to the user that this is the new price that I've got for this particular stock, and the users app updates it right away. So, but WebSocket is actually a two-way communication. So, ideally, user should also be sending something. Then actually we need a WebSocket. So we don't really need a WebSocket. We have a better technology called the server sent event.
Mhm.
So in server sent event, user sends a user hits ticker service. I mean, user hits a particular API of the ticker service, and that connection is basically kept alive. So that connection is not closed after the response. That connection is actually kept alive. So uh, whenever the ticker service has new update on the price, it actually sends a message through that connection to the user. So it's a one-way connection. It's a server to user connection. It's not a user to server and server to user duplex connection. It's only one-way connection, but server to user connection. So we have talked about this. So we will basically use the server sent event here rather than a website or simple HTTP. Now let's talk about
So I
exchange.
think I
Yeah,
think I talked about service and events in our FB live streaming video also,
yeah,
right? If I'm not wrong, right? Yeah.
yeah. We had talked about it. Yes.
Okay. Yeah. So which one is essentially heavy connection? Is it like WebSocket or service and event? Do you have an idea? Just just for curiosity.
Uh, so I'm not sure. I think on the backend side, I mean, both of them should be. So for a particular connection, we actually need to store the data in RAM. So I think that amount of data is actually same for both of them. The only thing is the security part. In WebSocket, we are allowing the user to send the message to our ticker service. So we are basically providing the functionality to the user which user does not use. So it basically opens a loophole. So that is one thing. And the other thing is WebSockets are a different kind of. So WebSockets are not actually built over HTTP. So they can actually be blocked by the firewalls, I think. But the server sent event is actually built over HTTP, so it won't be blocked over the firewall. So let's say if a firewall actually blocks the WebSocket connection, and it allows only HTTP connection. So in that case, server sent events will work, but the WebSocket might not work.
Yeah. So Karthik, what you were just saying is that uh, I mean the WebSocket connection will be first started as a handshake on top of HTTP, right? I mean, that's the first step that happens in any WebSocket connection. And then once it's upgraded to proper WebSocket connection, then it's like a completely different protocol altogether. But the first stage happens through HTTP or HTTPS handshaking only to upgrade the
Yeah.
connection to WebSocket. Now the problem with the firewall you're saying is that some firewalls might be able to block this upgrade header altogether in some way or other.
Yeah, yeah,
Is my understanding correct?
yeah, yeah, yeah. So yeah, that can happen actually. So
Okay.
that's why I mean server side event. It's basically a good idea. I mean, for other reasons as well, and one of them was this. So, like, uh,
Mm.
yeah, I think yeah, let's go ahead with that. So now the thing is basically, let's say when we were, so we have said that user will be connected to the ticker service through a server sent event connection,
Yeah.
and so here we have just assumed that there is just one single server
Yeah.
to which user is connected. But of
Yeah.
course, when we actually have 20 million users who would be using the website on, using our broker on daily basis. So even at a time, even if we take just 1 million users, that will be actually a lot,
Yeah.
and one single server will not be able to support all those connections. So that's
True.
why we would need a lot more servers
Mm.
to connect to the users.
Okay.
So now then, how would uh, how should the exchange, so after we have received the event from the exchange, how do we know that this particular user is connected to this particular server, and then
Mm.
this user has kind of subscribed to these many stocks, so we should
Yeah.
send the update to the user for these many, for these stocks. So that, but yeah, that we can maybe cover that part in later in the scale, or do you
Portfolio.
want me to cover it right away?
Yeah, I think let's cover it since we are into deep dive. So, uh, let's see the flow basically that when you get the data in the ticker cache from the exchange, how you actually propagate it to the users and how do you actually scale this part. Let's cover that. Yeah.
Okay. So before that, let me just cover one more thing here. So we actually didn't talk about how is ticker service connected to the exchange. So what is basically the connection protocol here? So it's
Okay.
basically, the use case here is very similar to the one we just talked about. So
Mm.
exchange, as soon as the exchange has the updated data for the stocks, it should send them the data to the ticker service, and this operation should happen as soon as possible. So we need a system which can, which should take as less time as possible.
Yeah.
So of course we should be able to do the same thing here as well, like we did for the ticker service.
Hmm.
We should be able to use the server sent event connection here as well. So ticker service actually sends a request to the exchange for the first time that maybe give me the uh, give me the
All the ticks, all the ticks. Yeah.
yeah, all the ticks for these stocks, and that connection is exchange responds with a header that keep alive. So so by reading that header, a ticker service will know that I have to keep alive this connection. I have to keep this connection alive. I want to be closing it, and through this connection only, your exchange would be sending the data to me. So but we can theoretically we use this server side event connection here as well, but
Mm.
we actually have a better protocol here which is
Mm.
called fast. So fast, this protocol works on a similar method, but it's only for the financial data. So the added benefit of this protocol is the protocol itself actually does the compression and decompression of the data, which is basically being passed through the connection. So for the financial data, it basically saves a lot of I would say network bandwidth, and the data would be transmitted faster than the server sentiment connection.
So does
So
it so does it do encryption also by any chance?
uh, if we were to do the encryption, then we can do the encryption. All the only thing is that we'll have to share the key as well. So uh,
I
yeah,
see. I mean, Yeah.
Yeah,
I mean, see, when you say compression, decompression, they are essentially supported by all the servers, more or less. So I'm assuming that whenever exchange is sending some data to the ticker service through this whatever you call fast protocol, the server will anyway compress the data, and our server will anyway decompress the data. So that anyway happens all the time. So
yeah,
is
yeah.
there any special compression that it applies, or that you spoke about?
So this compression is based, I mean, specific to the financial data. So
So payload
the thing
compression
is
in some way or
financial.
other?
Sorry,
The payload compression, I mean, one more level of compression on the
payload
payload.
compression is payload compression. Yeah.
Okay, okay.
So I mean, let's say if you know the structure of the message, that let's say we have a let's assume that we have a XML file as a
Mhm.
message that is shared. So you would know that the first line will always be uh, XML tag, and the last line will also be slash XML tag. So this is something that we already know. Now using this knowledge, we can actually make a better compression algorithm, which will know that the XML can just, let's say, be replaced with, let's say, a number zero. So XML is XML we replace with zero. So
Oh,
rather
I
than
see.
doing a slash, so something like that. So when we already
Ah,
know what kind of data is being transferred, what will be the most likely content of the data, we can actually do a better compression. So yeah, that's where the fast protocol comes.
I see. So is it like a persistent connection, or is it like just simple
It's a
HTTP
persistent
calls?
connection, yes. Yeah, so it's very much like server sent event only. The only difference here is it's specifically made for the financial data.
I see. So our ticker service will initiate this connection, and the exchange server will ask our service to keep it alive,
Yeah,
something like that, and then we'll actually keep it alive, and we'll continuously, upgrading the keep alive time or something like that, and
yeah.
there will be extra compression applied. So can you write it down the fast protocol on this arrow, and can you make this arrow bidirectional in that case? Is it kind of bidirectional, right? Or
No,
it's
it's
just
single. I mean, it's the other way
oh,
around actually.
oh, I see. So just write it as a first protocol, FAST.
Direction.
Yeah, capital you can FAST, capital FAST, I think, right? Yeah, first protocol.
Yeah.
Yeah, just to make it clear. Okay, I see.
So the assumption here is that ticker service has made a single connection with the exchange, and through this single connection, exchange is sending the data.
Mhm.
So, I mean, if it's possible, then we can go ahead with a single connection. But if not, then maybe we can have up to, let's say, 5 or 10 connections. So in any case, we have only like 10 to I think 20,000 companies. So for 20,000 companies, I think maybe maximum 10 connections would be enough. I mean, if we think that you know the amount of payload is basically sort of causing the congestion on the connection. So
Yeah, I think it's just a ticker value, right? So even if you have 20,000 companies, essentially just a company symbol and the current value of the stock price. And again, it is compressed in some way or other. So might be just a file dump which is compressed and then sent to our ticker service. And probably, yeah, probably one single connection should be fine. I mean,
yeah, yeah,
I don't know. It depends on probably after testing it,
yeah.
we can
I'm
determine
assuming
it.
for the worst case actually.
I
So
see.
let's
Okay.
say if one connection is not enough, then we can have multiple connections. So let's say we have 5 connections. In the first connection, let's say we just we have some 1,000 companies which we have pre-identified. For those 1,000 companies, we ask the data in the first connection. Then for the next thousand companies, we ask in the second connection. So something like that we can do. So it will be like we have made 10 different API calls rather than one single API
Okay.
call.
Got it. Kind
So
of
yeah, I mean,
paginated
uh,
response. I mean,
paginated. I mean, I won't call it paginated actually. Paginated is when uh, whole
yeah,
data you decide in terms of
yeah.
uh,
I mean, the if I would actually design this ticker service, I would not really care about how many companies are there. I would just simply ask the exchange to give me all the tickets. That's it. Now, how it gives me, I don't know. I don't care. I just want to receive it. Because I don't have any idea about how many companies are actually there, and I don't really care about it, right? So maybe once I ask the exchange should have some way to tell me that, okay, fine, I'm sending you the data on this persistent connection. So you don't need to really know how many companies are actually there. Uh, you will receive all the
Mhm.
bytes, and in the last byte, there will be some level of header or something, marking that byte as the last byte of, for now, right? And then our server can actually process the data and save it to our ticker cache,
Mhm.
right? So, okay,
Yeah,
so
that's fair assumption. Yeah.
yeah. So what is this ticker cache actually made of? Or what is the technology choice here?
You mean ticker? Okay, cache, ticker cache.
Yeah, yeah,
So
yeah.
we have 20,000 companies only,
Hmm.
and at a particular time we would be storing the latest values of those 20,000 companies, maybe some
Hmm.
additional metadata like when was it updated, last or something like that. But in any case, I mean, the amount of data doesn't look much, so we can actually go ahead with a with any key value cache, I would say. So any
Hmm.
key value
Hmm.
cache should be fine here. All we need
Okay.
is, I mean, the ticker symbol could be the key here, and in value we could just put anything. So we in value, I mean, in the value part, let's say if we just store the JSON and we kind of convert it to binary blob and then put it, that is also fine. So we don't really need any complicated data structure here. So we can actually go ahead with any cache. It could be Redis, it could be Memcache, or maybe Couchbase. Anything would be fine.
Okay, so probably as long as you are comfortable with the technology and as long as you have low maintenance of the technology, probably that you can use here. Because the
Yeah,
data is transient here. So even if you lose that cache for some moment, it actually doesn't matter. Uh, Even if ticker goes for a toss, uh,
yeah,
right? I mean, I don't know, it might create some impact while placing order. Other than that, you don't have an issue.
yeah,
Okay, so let's say that we are going to use Redis here. Okay, so now that we have data in the Redis, we have data coming from the exchange through fast protocol. How are we going to transfer this data to the individual users? I might be subscribing to 100 stocks, you might be subscribing to only 10 stocks. So how that
yeah.
processing happens?
So first thing is every user has a kind of watch list. So portfolio is also kind of watch list for, I mean, if we look from the perspective of ticker service. So from the
Yeah,
perspective of ticker service, portfolio plus watch list, basically they are the same thing. So each user has one watch list, and one user is basically watching the ticker values for those
yeah,
stocks. So let's say if we had just one server here for the ticker service, then how would it look like? So user basically, made a request to the ticker service that, keep giving the latest prices for these stocks. Ticker service, ticker service, let's say, stored that watch list in its own RAM, and then let's say we have two users, then for both of the users the watch list is stored in the RAM right now. And when the exchange basically sends the data for, let's say, one particular stock, so we need to have a way that we can identify that for this particular stock is subscribed by these many users. So let me kind of build a rough data structure here. So we
mhm,
kind of have two hash maps. One hash map is for user against, let's say, uh, the stocks, or maybe, let's say Microsoft. It's basically list of stocks. So list of, let's say, let me call it stock.
yeah. It looks like you like Microsoft stock too much. You keep on referring to this. Yeah, okay. Jokes apart. Yeah.
So this is the watch list for the particular user. Now we need when we have the data available for a particular stock, we need to know who are the users who have basically subscribed to this stock. So we need a stock against list of users. So something like this. So let's say we have this kind of hash map in our RAM, and of course we also need to have a way of knowing what is the uh, what is the I mean connection object. So for this particular user, this is the connection. So
Mhm.
let me call it for user, the what is the connection. So let's say we have the data ready for Microsoft, and we will go to here. We will identify all the list of users. So we got the list of users. Let's say there were 4 users. For all those 4 users, we will identify their connections, and to all those connections, we will basically send the latest value of the stock. So this is how it will work for the single ticker service. So now a single server of the ticker service. Now it has basically two problems mainly. One is this whole data is in ticker services RAM. So
Mhm. So I would say
the
let's keep
data
it
is
simple.
large.
I would say let's
Yeah.
keep it simple. The ticker cache that we have, right, which essentially just stores symbol to the value, current value, right? It can actually also store user to list of stocks and stocks to list of users. That data as well. I mean, that will be definitely a separate data structure. So Redis offers something like hash map, right? Something equivalent to hash map. So you can actually put this data there too. That users, this particular user has subscribed to this list of stock, and this stock is being subscribed by this list of users. So that will actually make sure that at least you ticker cache. I mean, you have all the transient data in the same caching, right? Which is anyway getting used by ticker service application, right? So that you don't need to manage another caching in the ticker service, right?
Mhm.
So,
Yeah.
yeah, and so that's one approach I think would be better. And definitely this user to connection, this is more of like a very application level thing, right? I mean, we can still manage it again in ticker caching, but we need to see how to actually put it when multiple applications are there.
Yeah. So so let's see how this, how this will work when we have single server here, single ticker server,
Yeah.
and multiple users. So
Okay.
user basically goes to the ticker service, stores that watch list in the Redis. If the watch list is not there, or maybe the watch list was updated, then it will basically update here. Now exchange basically sends the data to the ticker service. Ticker service now goes to Redis and finds out the list of users which are basically which have subscribed to the particular stock. For those users, ticker service will find out the connections, and on those connections it will propagate the latest data. So this
Yeah.
is how it will basically work for the ticker service. So now since we have reused the Redis, data part here is actually scalable. So if these things grow, we can actually scale it. So I mean, that is also very not say very great statement to say that Redis will stay scale automatically. But yeah, we can talk about that later when we have to partition it. Okay, let's first talk about what happens when we have to basically increase the number of servers, or let's say basically number of users have increased, since in our
Mhm.
case basically we have 20 million users. So
Yeah.
at one particular time, and there can be at least 1 million users who are connected to the ticker service.
Mhm.
So the first thing is one server cannot do, can't won't be able to do much here. So we need multiple servers. So let's say I have two servers here, T1. Let me just call it server one and server two. So we my user one is basically connected to the server one, and user two is connected to the server two. So user one, user one basically will call, asks S1 to add the wish list to the Redis. It will do that by calling the Redis. So this part is straightforward. What happens when Exchange sends the data? So when Exchange sends the data, Exchange should be sending the data to only one server. It cannot do to multiple servers. So I mean there is no sort of broadcast there. So what should happen is there should be some other server here which is connected to the Exchange.
I think, yeah,
And
yeah, you
now
are,
this connection, yeah,
yeah, yeah, go ahead.
this server is basically responsible for broadcasting that data to the different servers. So how it can do that? Let's say it got the data for Microsoft, so it has to broadcast that data to both of these servers, server 1 and server 2. So should it I mean by broadcasting I mean it actually means that sending the data. How do we send the data? So we can actually make the rest calls of these two servers. That is one way. But maybe Microsoft was not subscribed by any users on S2, so we are basically wasting that call. So what is a better way of doing that? And it's, I mean, we are also making the API calls of all these servers. So maybe, I mean, there can be basically issues with that. So a better way of doing it here, doing something like this could be introducing a queue in between. So let's say uh, this is my queue here, and this server basically published the data to this queue, and this queue will be basically subscribed by the servers. So I mean they essentially what we have to do is we need to identify uh, which are the servers who have subscribed to this particular stock. So we can so let's say we have if we have a single topic, and on single topic all the servers have subscribed. So should we do that, or
So I
we
think,
can make this?
yeah, I think we are a little bit overcomplicating here actually. So can I do one thing? I mean, so see, just to keep it maybe a little bit of simple, right? So this server, whatever you are saying, right? So what if we remove all these QN servers and everything, right? What if this server only talks to this exchange, and this server actually talks to this Redis cache, right?
Mhm.
And this S1, S2, what you talked about, right? So let's say users are
Mhm.
actually connected to this S1, and users are connected to S2 eventually, right? So these are essentially S1, S2. This is not ticket server. This is S1, and this one is S2, right? So users are actually connected to S1 or S2, let's say, right? And
Mhm.
this ticket server, right? This ticket server essentially knows, sorry, this ticker server essentially knows that which user is actually connected to which host and what is the connection ID, essentially, right? And it also knows user to stocks list. So the point is that whenever it gets a response from the exchange server, right,
Mhm.
it puts the data to the ticker cache and whatever, and it immediately retrieves the user to stock list subscription information, right? And it also reads if that user, the user is connected to which server actually, basically which host and what port, and it can then actually broadcast that information to that server,
Mhm.
right? So in that way, your ticker server is actually responsible for getting the exchange data, storing the data to the ticker cache, right? And
Mhm.
reading the connection information, and then broadcasting. that particular data to that particular server because the user is actually ultimately connected there.
Yeah.
So in that way, you don't need to manage any, what do you call this, queue or all these kind of things actually. In that way, it just becomes easier. So the ticker server can probably do some level of broadcasting, right? Uh, I don't know whether it should be broadcasting or it can actually directly talk to the server for the particular host for the particular connection. Right. You can actually tell the host that, hey, I have some data for this connection. You stream this data to the connection.
Yeah, I mean, so it can be done, when we have less number of these servers, S1 and S2. But in our case, what is happening here is we have 20 million users, and
Yeah,
uh,
it can be
as
done.
far as I
It can be scaled for even hundreds of servers also, right?
So the problem
Well,
is, let's say we have users who, I mean, who are listening to Microsoft stocks. I mean, these users are basically distributed across all the servers. Then the
mm,
ticker server will be basically making 100 API calls. So that is a problem here. So we need a basically a better way of broadcasting this data. So
no,
that's
I'm
where
not.
basically I will want to use the queue here.
Yeah, so first of all,
So
if you use queue, it will not. It will be latent system because that will be another point of bottleneck in the system. So the
yeah.
latency we cannot guarantee. Second, if you use API call, that again might not scale for the server. But if you use some level of broadcasting, is what I'm saying, it might be doable. Right. And also one more thing you need to look at is that these servers are in the same, basically in the same data center. The ticker server, the S1, S2, they are actually co-located essentially, right? So they are probably in the same subnetwork also. So the API call that you are talking about, that also actually might be faster even if you implement it. What do you think?
Uh, so I mean, if there is no congestion, or let's say Kafka. So Kafka, I mean, if there is no congestion on the Kafka, then it usually takes up to 10 milliseconds, end to end. So 10 milliseconds, I think I mean, should not be really be a big deal here. So, I mean, making API calls to all these servers, uh, that is something, I mean, which doesn't look scalable to me. So you won't I mean, in reality, in real life, you won't really be having a for loop which basically makes 100 API calls to all different servers.
Yeah, so that's
So
when
yeah,
the broadcasting comes into action. But uh,
mm.
any idea on how to actually use that broadcasting? I mean, that's why actually this UDP multicast or broadcast to those systems are there, right? We actually read in networking long back in our college days. That's what it is supposed to do here. I mean, I personally didn't use broadcasting or multicasting much in my, uh, in whatever systems I built directly. So, but do you think so that can be used here with this architecture?
I mean, I haven't really used that. So we talk about the broadcasting I mean, in case of exchange, but yeah, I mean, why we, I mean, but we don't really have to, use those, I mean, complicated things when we can, do things in a much simpler way. So maybe
Okay.
let's explore. Yeah, let me think of something. So one more thing that we can do here is just like we have user has made a server send connection with this with the server S1 and S2.
Mm-hmm.
Uh, S1 and S2 call can also have a server sent connection with the ticker service. So user makes a connection with S1, another user makes a connection with S2, and
Mm-hmm.
S1 and S2 they have actually made a connection with the ticker service. So in this case, what will happen is ticker service will at max have, let's say, 100, or maybe if let's say if a thousand connection servers, then maybe maximum 1,000 servers, 1,000
Mm-hmm.
connections. So how it will work is, once ticker service receives the data from the exchange, it will go to the cache, and in cache we will store one more entry here, which will look like this stock has been subscribed by these servers. So we will also basically make him keep an entry like this here. So
How will you get this entry?
this entry we will get. So let's say. I am a user. I basically subscribe to one stock. I go
Mm.
to S2. So in that request, basically S2 makes a call to the ticker service, and then or uh, uh, S2. I mean, should we create one connection for every single request? I mean, that's not what we should do. So we should have just one connection. So S2 will have a connection with the ticker service. Uh, but the thing is, if it's a SSC connection, then in that connection we cannot send the update to the ticker service that let's say I had subscribed to these stocks. Here is one more stock that I'm subscribing to right now.
I think
So
let's do this other way around. When the user
mm,
first logs in into the app makes a connection with the ticker service, and the ticker service tells the user to connect to S1 or S2. That hey, I mean, depending on busyness of S1 or S2 or some algorithm, it will be able to identify whether S1 is less busy, let's say, and it gives the user S1 that hey, you talk to S1, you get connected to S1, okay, and then the ticker service itself actually stores that uh, the user is connected to S1. So all the stocks which are to be shown to the user, this particular user, should be streamed to S1. You're getting the point, right? I mean, see, if you just think it naturally, the user app doesn't have any way to know which server to connect. So it will simply just connect to one of the application servers, and the application server can tell the user that hey, you connect to S1. I'm making an entry for you, and then the user creates an server sent connection, whatever, with S1 or S2, whatever, right? And now the ticker service has to find out some way so that it can take data from the cache and see which data to send to which server. That's what we need to figure out here.
so you are saying that user should directly connect to ticker service for the
User
first
user
basically.
for the first call, for the first short call, user connects to the ticker service or some yeah, connects to the ticker service, and the ticker service tells that hey, you connect to S1 persistently or you talk to S1, and with S1 it builds a server send connection. So that's a
So
persistent
user
connection between
will,
user and S1. Yeah.
I mean, user will then, ticker service in the response sends that this is the server that you have to connect to.
Yeah.
So user will have another call to that URL.
Yeah. Another call to that URL and creates a persistent server send connection. And meanwhile, the ticker service can store the host and connection details. I mean, host details basically, right? That this user is connected to this host.
This user is connected to this host.
Yeah.
But why do you need a user information? Why ticker service needs a user information? So ticker service ultimately just has to send the data to the server, those servers,
Yeah.
and those servers
So
figure
what you
out.
can do is that you can just fetch what are the stocks which are being subscribed by this user, and this user is connected to which host. Let's send all this data to this host. I mean, that's in a brute force way, right? Once you have the user to list of stocks data, once you have user to host details, you can just fetch all the symbols which are subscribed by this user, and then you just see which host this user is connected to, and you send all these details to that server. But there is one trade-off here. The problem is that multiple users can be connected to S1 who are subscribing essentially to the same stocks, right?
Yes.
So you
So,
might be
yeah.
ending up, sending the same stock details, same ticker details, right, to server, but for different users. So you can
Yeah.
the ticker service might send the server S1 that hey, for this user one, these are the ticker details. And now S1
Mhm.
knows user one is connected to which connection ID. So it can simply just string the data to the connection, right? So all this S1, S2, they just manage user to their own connection ID, and the ticker service manages user to which host actually it is connected to. So ticker service gets all the users
User,
subscribes.
which user is, no, I mean, that is a redundant information, right? Like,
Yeah,
so
that's a
users
trade-off
can,
in. Sorry. Yeah.
yeah, I mean, we have 20 million users. So in cache, there might be 20 million users, 20 million entries against a single stock. So for example, Apple is a pretty popular stock. So let's say all the users basically subscribe to Apple. So against just Apple, we have 20 million entries. So even if you
Yeah,
had to
that's
do
what I'm
a
saying.
normal loop in
That's what I'm
i5
saying.
processor,
There's a
it will
trade-off.
still take 1 second. Yeah.
Yeah.
So
So definitely
basically, I mean,
that's a trade-off. Yeah.
I mean, yeah. So I mean, it's actually a big trade-off that it's almost not doable. So rather than doing that, what we can do is basically this stock has been subscribed with by these servers. So if we just manage that information in the cache, and ticker service basically just broadcast that data to those servers, and those servers can figure out that
But how do you figure out that information? Because
so
these servers are actually not caring about the tickers, right? Users are caring about the
yeah,
tickers.
yeah, yeah. So that information we will store in the Redis itself. But the thing is that information can be partitioned actually. So that information we can that how do we partition that? So yeah, what is the data that we need? We basically need that this user has subscribed to these stocks. So we can actually,
Yeah.
let's say if we have five partitions of the Redis, then we can partition based on the user ID. So that part is still scalable. The problem here is, I mean, if we try to find all the users for a particular stock, this information cannot be. I mean, it can be partitioned, but it will be scattered together if we had to do this.
No, hold
So
on. I'm getting a little confused here. We are not, first of all, we are not talking about scaling the Redis part here. We're just talking
mhm.
about how efficiently you figure out that what data to send to S1 or S2, right?
Yes,
So
yes,
instead of sending per user data, you want to basically just send a list of tickers, which will eventually serve those, what do you call it, those users,
yes,
right? So,
yeah. So here we will just say that for Microsoft, this is the current price. Let's say 360. Only this information will be sent to S1 and maybe to S2, and then S1 and S2 they will figure out who are the users who are connected to me. So that information can be stored in their RAM as well, and that information we can store in the Redis as well. So I mean, if we really stretch the number of connections to one server, uh, it can go up to, let's say, 100,000. And 100,000, I mean, for those 100,000 users, the connection object we are still storing in the RAM. So for those, actually, we can, but
so we'll go to
and
that.
then
But I think what you are just trying to tell here is that the ticker service gets the broadcasted information from the exchange, and it again
yes,
simply broadcasts all this information to S1, S2, S3, and everything, right?
yes, yes,
And
yeah,
now S1 and S2 decides that which users are actually subscribed to this particular stock,
yeah,
so that it can stream it back to them,
yeah,
right? Now the point is that this S1, S2 needs to manage that which user is connected to which connection ID,
yes, yes,
and also it needs to talk to this Redis cache to figure out which users are subscribed to this MSFT or these kind of stocks. So it will query the Redis by the stock symbol to find out list of users, and then let's say in a for loop, it will find out all the connection ID for those users and send the MSFT stock ticker to that connection.
yeah.
But that's also a little bit trade-off here because a user might, I mean, it might need to do some level of batching also to just make it optimized, but I think we are overcomplicating it. Yeah.
So the thing is, one user can have on average 50 stocks in their wishlist or portfolio. Maximum 100, but I'm taking an average of 50. So let's say if we have 100,000 connections to one server, then it comes around 5 million entries that we
Mhm.
have to store. So 5 million entries can be stored in the RAM of I mean these servers as well. I mean we will keep a copy of these in Redis, but they can also be stored in the RAM here. So basically, the
Yeah,
in memory cache here.
yeah.
So that part we can optimize. So we don't really have to call Redis every single time we get the data from the ticker.
But the
And
only point is that, but the only point is that it has to refresh this data after some point in time. I mean,
so we can
it's
actually do
like,
a yeah, sort of write back cache approach here. So I mean, whenever user updates an entry there in their portfolio,
Mhm.
that request will go to that server, and then that server basically knows that it has to be updated, so it will go ahead and update in the Redis, and it will also update its own uh, memory.
I mean, why can't
So
we keep it just, why can't we just keep it simple? I mean, let's say that we have some TTL mechanism of this data of
mhm.
say 5 hours or 6 hours or something like that. And once the TTL expires, we get the data. I mean, 5 hour might be too much, maybe 1 hour or maybe 30 minute TTL. Every 30 minutes we fetch the user the stock to user subscription details from Redis. I mean, the point is that it does it need to be exactly real time. I mean, I understand that whenever you use Zerodha and you kind of add something to your watch list, it's immediately visible, right? Uh, there is no lag, and you immediately start getting all the ticker symbols. Yeah.
uh, so I mean, we need to think of the case, why do we really why do we actually, I mean, in which scenario the data will be what do I call it? I mean, the data doesn't say stay updated. I mean, it's basically older data. What is the scenario? So my user is basically connected to S1 only, and that data is basically stored in the S1 only, and another copy is basically stored in the Redis. So all the calls are going through the S1 only, and if user updates their wish list or portfolio, the only problem is, let's say if user disconnects in between, then S1 doesn't know that
No, hold
S1
on.
doesn't that we need to remove this.
S1 and S2 are only just uh, for ticker use case because you are talking to, let's say, order service also, right? You are talking to portfolio service also. So when you add
Mhm.
something to your portfolio, your actual call is going to the portfolio service. So that flow knows which portfolio you have or watch list, right? Which symbols you have added to your watch list. So S1, S2 doesn't know.
Yes, yes, yes. I mean, the final source of truth is actually portfolio database, not the
Final
Redis.
source of truth is portfolio database. There could be some way to stream, I mean, to stream that data to Redis. We can figure out that. But in no way S1 or S2 knows that there is some recent update to your portfolio or to your watch list.
Hmm. I mean,
It can
we
only
can.
know it, it can only know if, let's say, some data is updated in the Redis and Redis has webhook mechanism. Okay, Redis has some level of callback mechanism. Redis
Mhm.
callback tells S1 or S2 that hey, this data changed, but I think that will be too much of complications here. So one easier
Yeah,
solution that I can think of
we,
is that S1 and S2 either they can directly talk to Redis. If they are not directly talking to Redis, assuming that that call will be latent, uh, if it keeps data in memory, then it has to refresh the in-memory data after every 5 minute, 10 minute, or 30 minute, whatever suits the bill here. That will be much easier solution to manage. But I'd still argue if we are in the same subnetwork, you're in the same uh, network, then S1 calling Redis for the data is not going to be costly, probably.
it's been calling Redis.
Redis,
Uh,
let's say every 5 minute or every 10 minute or every 30 minute directly to just refresh his own data is not going to be costly, right?
so I mean, and that actually depends on the amount of data transfer actually. So I mean, in one, so we need for each. I mean, for each update, we basically need we have 5 million entries. Uh, yeah, it was 100,000 into 50, so 100,000 to 50 stocks. So for one stock, we need to find the users. These are the users that we can find from the Redis. So one stock can be 20 million users, the data of 20 million users.
What is the issue that you're talking about here?
So let's say if we don't maintain the data on S1 and S2, we maintain the data in the Redis itself. And let's say we have a list here,
Mm-hmm.
stock versus list of user,
Mm.
this one. Now we got the data from for Microsoft 360. I mean
Mm.
propagated to S1. Now S1
Mm.
needs to know who are the users who have subscribed
Mm.
to this stock.
Mm.
So it will go to Redis. It will, ask the entry in this map. But the only
Mm.
problem here is this list can be very big. It can go up to 20 million. So this 20 million list, it will be sent to the S1. And if this 20 million list takes, uh, it actually depends on what data we are storing there. Let's say 20 bytes to 30 bytes, 50 bytes, let's say. So 50 bytes, 1000. Yeah, let's say
See, there will be some level of compression applied on the data also, when it is stored on Redis and when it is transferred over the network, right? Uh, I mean, 20
I
million
mean,
is again a very worst case scenario, right? We're not sure even 20 million users will be there, but assuming that users will be there, right? Uh, I mean, what I'm just saying is that these data, even if we don't make these data strongly consistent, it doesn't matter. So once you fetch these data once, let's assume that the data can be transferred through an API call, let's say, right? Once you get the data, you can cache it for 5 minutes maybe, right? And after 5 minutes, you are again going to make a call. So you are not going to make this call all the time. You are going to make this call periodically.
so the only problem is basically, let's say if a user, adds one stock in their um, wish list. In worst case, it can happen that after 5 minutes, user sees the actually starts seeing the prices
I mean,
if we
if you add it
rely on
to
that.
if you add it to watch list, the user will make an API call, right, to add it to an watch list. So we can serve that points value to the user, but it won't be updated for 5 minutes. So it will see the initial value, but in the worst case, after 5 minutes, it will see the ticket changing because that 5 minutes it will take to propagate the data from Redis to S1 in the worst case or S2.
Yeah, I mean, it still doesn't look like a very good experience to me. So I mean, one more thing that we can do is here is see, when we are updating the portfolio, we are anyway making the call to portfolio service, and
Mm-hmm.
portfolio service storing the data in the portfolio database. So
Mm-hmm.
let's say if we use change data capture, or even if we don't use the change data capture here, what we
Mm-hmm.
can do is we put in a queue here. So and we basically publish this event, the changed event to this queue, and this queue has been subscribed by these servers. So these servers can then update their caches immediately. So that will still be a good experience, I feel. And also not a very complicated system. I mean, we do introduce one more queue here, but I think the
Yeah,
user
again, you
experience.
need to again see that's what I'm saying. No, that's a trade-off that how much user experience actually matters here for just a ticker. Um, I mean, for just a ticker to be completely real time, that too for the first 5 minutes in the worst case for many users, should we make this system complicated by introducing another level of queue and the subscription and all these kind of things?
So actually for intraday traders, actually I think it will matter because they have to take this decision immediately, which is why I feel.
Mhm. So what if you reduce the TTL from 5 minutes to let's say 2 minutes or to 1 minute? Every 1 minute you can actually fetch a data. S1 or S2 they fetch data from Redis and they update their cache.
I mean, for intraday traders, actually it's still not good enough. Maybe for other kind of traders, I mean, it will work. The problem with that is that, I mean, we'll have to basically, call Redis much more often to get the latest portfolio or
Yeah, I'm not
boost.
a. I think it's more of like a very business or very product centric decision as of now, right now, right? Uh, but yeah, I mean, just for the sake of some use case, complicating the system is something which I'm not a big proponent of, right? So yeah, maybe this is the two different kind of approaches that ideally we can probably discuss with in real life with the product team and decide which one to go for,
Mhm.
right? Right. So the queue scenario will only work best if you actually have intraday traders or those kind of people. Okay. So these are two approaches anyway. The result is depends. The result is dependent on the product decision, which we can't take right now. But would you like to add anything to this flow? Anything else to add here?
Yeah, so if we were basically going to do, rely on, user connecting to the S1 and S2 and then, they connecting to the ticker service and all, then rather than using SSE here, we will have to use WebSocket because the in many cases, basically these servers will have to send the data to the ticker service. So that's why we need a two-way communication rather than one way.
What data will be sent?
So let's say if I update my portfolio,
Mhm.
uh, if I update my portfolio, then okay, this will be written this way.
You have the queue, right?
The data. Yeah, yeah.
I mean, we have purposefully put queue for that purpose only. And also, you should not rely on the user
No, no, no.
to
So
propagate that
let's.
data to.
So the thing is actually user. Let's say I'm user one. User one basically made a call to S2, and S2 basically S2 made a call to the ticker service to
Mhm.
get the to subscribe to those stocks. Now another user comes, let's say S4, sorry,
Mhm.
user 3. User
Mhm.
3 is connects to the S2 as well. Now
Mhm.
what should happen for this user? Because there is one more user who has basically subscribed here now
Mhm.
to maybe another stock from the same server. So this information we basically have to propagate to the ticker service so that ticker service knows, or maybe this information should be stored in the Redis or somewhere else. Yeah, if they
No, I
can
think I
basically
think yeah, I think let's be very specific about the role of S1 and S2. I mean, to me, it's simpler
Mhm,
to manage this system if S1 and S2 only streams ticker data to user in a single connected in a single way connection. The S1 and S2
mhm,
are pushing data to user, and primarily the data is nothing but the ticker values. That's it. And let's say that for now we have queue. So if a new user comes, right? New user connects to let's say S3. Okay. And meanwhile, new user tries to subscribe to some watch list or portfolio or add some, execute some order and whatnot, right? So it will be different connection. It will be different call HTTP call to the portfolio service. And the portfolio service can push this can push this event to the queue, right?
mhm.
And, or at the same time, there should be some way so that the portfolio service can update this data to this, you know, ticker cache also because we are actually maintaining a cache. That data also needs to be updated.
Mm-hmm.
It's not only that S1 and S2 needs an update, it's also the Redis cache needs an update,
Yes.
right? So
Mm-hmm.
yeah, I think we still can do that just by calling the, whatever Redis is there, just by calling that and adding this entry, right? I mean, we can write a theme wrapper on top of Redis, basically, which is just a service like proxy, which will be called by this portfolio service to write this data directly to Redis if scale is not a concern, right? Since it's a single call anyway uh, for a single user. So I think from my point of view, S1 and S2 should be only making a single, should be maintaining a single way connection with their own users. And the data should be streamed from the servers to the user, not the other way around, just to keep the system simple.
Hmm. Yeah, actually, yeah, if we directly update the Redis, then ticker service can uh, ticker service has the connections, and these through these connections it can basically send those information. Yeah, yeah, we don't need a WebSocket here.
Yeah. So let them be SSE only. Yeah. Let them be SSE and yeah. And the portfolio system should somehow be able to update the Redis. Right now, whether it does through the queue or directly, I think I would prefer directly because not, I mean, a user not all the time updates portfolio or updates their watch list, right? It's not a frequent operation. So scale might be manageable there, even if you just call the Redis wrapper. Yeah, so let me draw it like this. So the portfolio service will update Redis directly. So now if you do this right, I think the queue requirement might actually become optional. I mean, let's say that when the user has added something to watch list or portfolio, we have already
Hmm.
updated we have already updated Redis, and the user now sees the current ticker value. And in maximum, let's say in 2 minutes time, anyway, S1 or S2, they are actually going to update themselves, right? So in that way, just I mean, if it is not very crucial or very essential, maybe the queue also can be removed altogether, unless and until the intra-day data that you are saying that use case probably comes up.
Yeah.
Yeah. So this kind of becomes optional in that case, right? Okay, cool. Do you want to add anything else here in this flow?
Yeah, I think we can move on.
Okay. So now there are different databases, order database or wallet and portfolio also. So how can we actually scale them? Uh, how can we actually partition the data? Because I'm assuming that we'll need some level of partitioning because we have millions of users. So what do you think?
So, I mean, let's first talk about the portfolio database. So, portfolio,
Mhm.
we have assumed that for one particular user can have up to 50 tickers in their portfolio. So, which means for all the users, we have 20 million users, it can basically come around 1 billion. So, let's say if we go ahead with a relational database and we sort of, build a table. So, that table will have 1 billion entries. So 1 billion entries can actually come on one machine if the machine is really big, but you don't really do that. So that's why we need some sort of partitioning. So
Mhm.
now, should we go ahead with the relational database or should we go ahead with the non-relational database? So let's first discuss about what are the options that we have in the relational databases. So
Mhm.
in relational, we know that relational databases are not really the distributed databases, which
Mhm.
basically means that they reside on a single service. Of course they can be replicas and all on different machines, but again the right actually comes to the single server. So single server is basically the main database. These are just the sort of backups, so that we don't really consider them. So that's why basically it's not relational databases are not the distributed databases. So how do we
Mhm.
make them distributed? I mean, how do we basically partition them? So what we can do is, let's say instead of having one machine, let's say we have five machines. So we use five machines, and some of the traffic we migrate to first machine, some of the traffic we migrate to the second machine, something like that. But of course, we need to have a way to know which traffic should be migrated to the first database,
Mhm.
first server, and the which should be maybe migrated to the other servers.
Mhm.
So here basically what comes is the partitioning strategy. So we know that there can be two kind of partitioning strategies. The static partitioning strategy, which is basically a kind of hash based partitioning. So you divide you maybe, let's say you take a hash of, let's say, portfolio ID, and portfolio ID or user ID, and then you hash it by 5, and then you uh, to all the users,
Mhm.
hash value was 0. They all will basically go to the
Yeah.
first DB. So this is kind of static partitioning. The other is dynamic kind of partitioning, where we keep we can basically the partitioning is dynamic. So maybe today user one's data was on the or on DB1. Tomorrow maybe it was migrated to a newer server we added basically. So that is a kind of dynamic partitioning. So in relational databases, actually dynamic partitioning is not so easy. So I mean, you can go ahead and try to build, but that kind of defeats the purpose of using a relational database, because among these partitions you cannot guarantee the asset properties, but you can still do that. So the simple partitioning strategy that we know I know is for Postgres. There are some extensions in the market, so you can use those extensions, and you can basically divide your tables in such a way that some part of the table will go to the one database, and some part of the table will go to other database, something like that. But again, it's a static partitioning, it's not dynamic partitioning. So should we really go ahead with the go ahead and think about dynamic partitioning? So that is actually a question of what kind of data you have. So what do you think on this?
So first of all, our data is kind of relational, not kind of, it's actually relational in nature, right?
Mhm.
So relational database would be required. Second, we'll be probably needing transaction because it's a financial system anyway, right? So third is that uh, I think on the question of static and dynamic, uh, unless and until we determine the scale, it will be very hard to know that how many machines we are going to have, right? So maybe what is the current traffic into, let's say, 10 is what is the expected scale in the next, let's say, 3 years, as an example. And accordingly, we can assign number of machines. And then maybe we can see, right, if uh, some particular range of users should fall into some partition, another particular range of users should fall into another partition. That's probably one way of doing it. I mean, there are different kind of data. You need to actually identify the query pattern, which is the most frequent query pattern. Let's say order database, right? So whether you want to
Mhm.
collocate orders of the same user to the same partition, or you just want to, partition by simply order ID, right? Let's say that you identify some hash of the order ID, and based on that you assign some static partition, right? And if that way, what will happen is that uh, your orders are going to be evenly distributed across machines. But if we partition by user, it will be very difficult to know for some user if it something might become actually hot partition or not, right? So in that case, we might need to assign some particular user to certain machines. Basically, we need to override certain configurations maybe, or write some proxy layer which will probably assign certain users to certain machines. So I
Mm-hmm.
think that we should probably take a hybrid approach here. I mean, uh, if we just I mean, first of all, we need to identify the kind of query that is going to be frequent, if it is order query or if it is per user queries, right? If it is per user queries, maybe we actually assign static partitions that less than all the users with hash of user ID less than 1000 should reside in P0. Hash of user ID less than 2000 should reside in partition 1, and so on. And if there is some hot partition, there should be some way so that we can actually migrate that users, I mean, those basically hot users from that particular partition to some bigger machine, right? And I think hot partition problem is anyway going to be there in some way or other, actually. I mean, that's something that you cannot actually skip off. So I think to answer your question in some way or other, we can start with static partition. And if there is some hotness, we can just keep on migrating those particular segments into some bigger machines.
But of course, that cannot be done dynamically, so that will have to be done, manually.
Yeah, I think that's fine, right? Because anyway, I mean, it's probably few cases where it's actually going to be hot, right? I mean, probably for big, I mean, or you can do also one more thing. Let's say we support normal retail users and we support institutional users. Now, institutional users might have more transactions. So we can specify different set of machines for those institutional investors altogether, different cluster, right? And for retail users, we can have a different cluster altogether. So you might be having very dynamic movement of partitions from one machine to another machine in case of institutional users. And for retail users, it might be a little bit stable, right? So your static partition might work well for retail users once you have some peak QPS figures and you have number of machines decided. But probably for institutional users or FIIs or anyone who invests through this platform, there might be some level of dynamism might be there,
Yeah,
right? So it can be a hybrid approach is what I think. What do you think?
yeah, yeah. So, I mean, to the people, I mean, people might not be familiar, but there is one database in the market. It's called Espresso database. So Espresso is basically a SQL database, but I mean, it's basically a database that is built over MySQL, and but it basically provides an ACID guarantees within the partition. So I mean, it's highly scalable. It's a distributed database. Within partition, it provides all the ACID guarantees, but across partitions, it doesn't, provide those guarantees. So maybe basically something like that we are, talking about. So in Espresso, what happens is the whole data is actually divided into partitions. So there, I mean, it starts with 64 partitions, and you can configure them up to I think 256 partitions. So you can go up to I think 256 partitions. So rather than inconsistent hashing, the ranges are pretty dynamic. So rather than doing that, what basically happens here is, let's say if there is hard partition kind of issue, then some of the partitions are just directly taken from that particular server, and then they are moved to another
Yeah,
server. So maybe that kind of approach we can take here. But
yeah.
if you don't want to use the, that database, basically having a simple static kind of a partitioning strategy would also work here. And
I
of
think
course,
yeah,
separate system for FIIs. Yeah, I mean institutional
yeah.
investors.
Yeah, now this brings me to a very interesting question. So this is kind of let's say that there are many distributed databases altogether in the market, right? Which
Yeah,
actually guarantee you that you can do transactions on different partitions altogether, but definitely at the cost of
yeah,
latency. So
yeah.
it brings me to a question like build versus buy decision. So how do you know that you have to buy a solution versus how do you know that you have to build a solution? What do you think? What are those parameters?
So first thing is basically when you are going to build a system of something like a database, it's going to be really complicated. So there are so many edge cases actually. Even most of senior application developers don't know in the databases. So there are so many low level details. So that is something which is going to be really complicated. So I mean, if you think that this is uh, something that is very straightforward, there can be no edge cases, then you can maybe try to build it. But it's, I mean, usually not a very good idea, I would say.
I think
So
I think all we're talking about building here the control plane of the database. That's it. We are actually not building the Postgres database or any distributed database altogether. It's just the control plane of the database, right?
mhm,
We are not in the data plane, first of all. I think one more thing that actually comes into consideration is the cost of the system. So if you opt for any SaaS solutions, right, or any other vendor, so there will be vendor lock-ins, and you will have dependency on the vendor to actually for to support some features, and definitely the cost increases, right? I mean, if you even consider the cloud databases or any cloud solution, the cost keeps on increasing every year with more number of usages and with their policy changes and different other things. Probably that is the reason many companies actually prefer to manage these systems or build the control plane in by themselves. So the whole control is actually with them. Definitely, there is a cost of understanding the whole system and maintaining the whole system, but that cost in terms of developer velocity, in terms of actual dollars cost, is much lesser than what you are actually going to have with probably with a SaaS solution or with a vendor lock-in, right?
yeah,
And if you can, there are again some low level details also, like if you can manage proper indexes, if you can identify that what will be your data size and how many partitions will be sufficient for the next short term 3 to 5 years, let's say. And at the same time, if you can efficiently use connection pools, maybe, or if you can basically if you can optimize each and every layer of your applications uh, to DB connection level, uh, probably you will be better off actually building this system yourself than actually depending on someone else, unless and until you really have that scale.
yeah.
So I think all these things actually go behind this build versus buy decision. It's easy to buy if you have a lot of money, but if you just apply some common sense, maybe you can optimize many different layers, and you can have control, and you can actually save a lot of dollars out of it if you build it in house, specifically the control plane, right? Okay. Apart from that, I think we have one more critical flow to cover, this wallet thing, right? You remember we have this wallet discussion that you add something to wallet and the payment service is also involved. Uh, what if payment service fails? Or what if wallet database update fails? That's a very critical flow because it's a money transaction. So how do you solve it?
uh so basically your system is, user connects to the wallet service to, update some, add some money to the wallet service. Gets a Wallet service basically provides a transaction ID, which is basically used as a idempotency key throughout the system. Then so payment service and this payment gateway and all these things, so they will happen. I mean, these things basically cannot be done, in a single database level transaction. So these things will just happen. Once the payment is done, payment gateway has provided the response to the payment service, which is usually through a webhook. So let me basically add a diagram here. So payment gateway basically called the webhook of the payment service, and basically sent a success response that this much money was successfully transferred from user's account.
Mm,
Now payment service has to call the wallet service, or I mean payment service is basically, propagates that information to the wallet service. So wallet service will, take that transaction ID, and it will basically go to the wallet database. So wallet database should have sort of two tables here. One
mm,
is, let's say, just the wallet information, which looks like we have a user ID, and then let's say current balance,
mm.
and maybe we can keep information like last modified or those kind of
Yeah,
things.
yeah.
The other table is basically, we should also store all the transactions that have happened. So transaction should have transaction ID, which should be the primary key, and
Mm.
then maybe amount, and then other things like user ID and those kind of things. Maybe it was a credit or debit,
Yeah,
credit slash.
payment method, whatever. Basically,
Not
payment method
method
details.
actually, not exactly method actually. I'm talking about I mean,
Okay.
this amount was credited to user's wallet, or this amount was basically
Oh, I
debited
see.
from, yeah,
Oh, got it. Okay.
or debit.
Okay. Yeah.
So essentially, at the end of day, all the credit should be equal to debit.
Hmm.
Something. I mean, basically, this transactions is actually a ledger. So it should not.
Mm.
So it should be open to additions, but it should not be open to modifications. So we need to basically add a constraint on this table that service can add an entry here, but service cannot modify any existing transaction. So we are basically going to basically put a constraint on this table. So that will ensure that that will basically, I mean, the whole purpose basically to ensure this thing. So if we did not modify anything, it basically becomes atomic. I mean, these are basically atomic transactions. So at the end of day, if we add all the debit credit transactions, they should be equal to the all the debit transactions. Now, so wallet service makes a call. Wallet service basically has got the transaction, successful transaction. So it will basically call the wallet database within the, and these two, I mean, these two entries will be updated. I mean, these two tables will be updated. So we will be adding one entry in the transaction table, and we will be updating the current balance in the wallet table. So of
Mm.
course, these two tables should be updated in a single transaction. That is one thing. That's why we need basically acid thing here on this database. So that's why we need a SQL database for the wallet database definitely. And
Yeah.
uh, yeah, so if any of these transactions fails, then the whole transaction will be reverted. That is one thing. uh,
So the only thing is
so
I'm little bit concerned about this payments gateway. Let's say the payment gateway response is lost. Then
mhm.
how will actually update the wallet? So so payment gateway can respond back to us in the same API call or maybe in a OA book, whatever way it is. We need to make sure
Uh-huh.
that we actually update the same thing in a wallet properly. So that thing should not actually fail, right? Now, once the OA
Yeah,
book
so
requests callback come to us,
that
what do you do?
actually, yeah, that is a very kind of known failure scenario that happens with the payment gateway. So it's possible that payment gateway tried to update, tried to call the webhook, and somehow that call did not succeed, or payment service was down at that time. So there are some strategies, basically some methods which are provided by the payment gateway there. So one method is basically payment gateway will try again after some time, and basically these retries can be of exponential back of kind. So where the second retry maybe you make after 1 minute, and then third will be made after maybe 2 minutes, and the fourth will be made after 4 minutes. So it
Mm.
exponentially, basically the delay basically keeps increasing in an exponential manner. And for the final thing, basically payment gateways also provide a sort of file that you have to download from them. Using
Mm.
that file, basically you can do the reconciliation on your end. So that also we need to do at the end of day, or maybe at any other particular intervals. So yeah, it's basically, I mean, it also depends on payment gateway. It's kind of very mixed kind of system, but roughly this is how it works.
I see. So if there is some discrepancy, we might need to show to the user that hey, uh, we are going to credit to your wallet, but if there is some issue, we'll return it back to your original, payment method, right?
Yeah,
Or
yeah,
bank account or credit card or whatever.
yeah.
Uh-huh, I see. Okay. So there is no way that we can actually directly make sure that the whole thing is done in a proper transactional manner? I mean, depends
Uh,
on the API
I
probably.
mean,
I mean, is there any particular way the payment gateway just always replies back by webhook, or because it depends on their API, right? I mean, is it always the case that there is some callback, or it can be done in the same API also?
so the thing is, I mean, the call from payment service will go to the payment gateway. From payment gateway, it will go to the bank, and then so there can be actually a chain of calls.
Hmm.
So maybe they made a call to one bank, and then that bank basically makes a call to another bank. So
Yeah.
that's why it basically takes time. So
Hmm.
since it takes time, so I mean, uh, user is actually redirected to the I mean, to the payment service, or the initial service, which kind of works in a sync manner. But usually what happens is, you went to the payment gateway page, you provided your information, then there will be a sort of loader that will be loading, and then it will say that payment was successful, then it will redirect you back to the payment service.
Hmm.
So I mean, calling it single transaction, I mean, basically it
Okay.
takes time, maybe 30 seconds or
Yeah.
something, maybe 1 minute. So in single request, I don't think it can be done. So that's why you
Okay.
need, something
Okay.
of
Okay.
like
And
that.
also there should be some level of idempotency key supplied to this payment gateway also, right?
Yeah.
Just in
So
case.
so this transaction ID, this will work as a idempotency key in our whole system. So idempotency is something that basically the client generates. So our
True.
client, I mean, client is basically us. I mean, for payment gateway, we are the client. So the client has to generate the idempotency key, and that key will be sent to the payment gateway when we are trying to make a payment. And that idempotency key will be used by the payment gateway to send the response in the webhook.
Hmm.
So, and what we have basically done here is, when user made the call to wallet service to update the wallet, at the in the very first call we actually made a transaction ID, and this transaction ID is actually going to be used as a
Hmm.
idempotency key in our whole system. So that's why, so that there is no scope of duplication anywhere.
Hmm.
So,
Got it.
yeah.
Okay. Makes sense. Okay. I think we have just few minutes left. So would you like to talk about the deployment and overall monitoring of the system, just to make sure that the system is fully functional, right? And we get any alert or anything like that whenever something goes for a toss.
Yeah, so before that, let me talk about a failure scenario that can happen. So since we talked about that, these two updates should happen in single transaction.
Hmm.
So let's say, I mean, these updates were happening when the payment was actually successful. They were
Hmm.
actually happening after that.
Hmm.
So since that means that there will be scenarios when this whole transaction was reverted. So what do we
Hmm.
do in that case? So that means basically the money could not be added to user's wallet. So that's what
Hmm.
basically happened. But the money was actually deducted from user's account. So in that case, actually, we can go ahead with maybe retries from the wallet service. But the problem with the retries is that it's a non-deterministic kind of system. So we don't know which retry will succeed, or when it will succeed. So better is to basically just say to the user that there was some technical error on our end, and due to some issue the money could not be added into your wallet. If it was deducted from your end, then it will be transferred back to your account within 3 to 5 business days, something like that, which is basically everybody does.
Yeah.
So yeah.
Okay.
Since we talked about this failure scenario, let's say if this failure scenario happens a lot. So if it's happening a lot, then definitely not a great idea. So we could actually put an alert on this particular scenario, or maybe
Hmm.
the scenario here is basically these kind of transactions should are failing. So we could monitor the number of transactions failing to the wallet database. If that exceeds a particular
threshold.
limit, we basically
Yeah,
alert the user.
yeah.
Uh,
So
that is
basically,
one
basically,
critical
this
component. Yeah.
these transactions will have some status like initiated or success or failure or in progress, something like that, right? So if some
Hmm.
transactions or number of in progress transactions exceed some threshold for certain time period, the alert can be generated, right?
Yeah.
So because it has to finish either success or fail, or if number of failures is also more, maybe your payment gateway is not working properly. That should be also part of the alert.
Yeah. Payment gateway, let's say, if this part is also failing, then also we should raise alert. So
Yeah.
I mean, what we can do in that case is basically we can maybe we have an option to manually switch to some other payment gateway. So that's why it's important to raise the alert here as well.
Mm, yeah. True.
Other
Yeah.
thing could be maybe so these servers are actually kind of they will be highly overloaded. So a lot of people are basically connected to them. Maybe we could monitor the number of connections to these. Uh,
I mean, there should be some level of monitoring here on the number of connections. Otherwise, the ticket service won't get to know, which server the user should be connected to. I mean, it can definitely do round robin. It can definitely
yeah,
do round robin. Uh, but again, do we actually want to load ticker server with all these kind of algorithms? Is another question, right? So maybe round robin is the way to go, which will be homogeneously distributed, right? Or there should be some level of library which should be able to do that, like how load balancers actually do, right? So yeah, but
yeah,
in any case, if we end up having more connections to our servers, we can generate alert for that, right? And I
yeah,
think in a similar way, we can try to see the uh, pressure on Redis. I think Redis comes with some already inbuilt, uh, not inbuilt exactly. I mean, some plugins like or some monitoring process like Sentinel, which essentially monitors Redis, its performance metrics and stuff like that. So we can actually utilize them here to actually see how our cache is actually performing, right? Yeah, apart from that, I think all the external calls can be monitored. So whether the exchange call actually works or not.
yeah. Always a
And
good idea to monitor the third parties actually. So
yeah, any
exchange,
dependencies.
yeah, any dependencies.
And also how the latency of the round trip time looks like, for the database queries. That also can be monitored,
Yeah,
right? Yeah, and I think in short, let's just take few seconds. So for deployment, I think we decided that for this problem, probably we are going to host it in-house, right?
yeah.
So
So if we talk about deployment, actually for the stateless servers, the deployment is easy. You basically take one server out of the rotation and you deploy a new code, and then you maybe put it back into the cluster,
yeah,
or maybe rotation. But these servers, I mean, these are basically stateful servers. So here the deployment will not be that easy. So we will have to drain the connections. Once these servers have no connections anymore, then only we can do our deployment here. So deployment is actually a sort of tricky part here. So you can actually either just all I mean you I mean one way is basically you ask all the users to disconnect at once. uh, I mean, let's say if you are trying to deploy your code on S1, so whoever the users who are connected to S1, you ask all the users to basically disconnect. Then they will all disconnect, and then we basically take S1 out of rotation. Then we deploy our code changes on S1. Then so the problem here is basically, let's say we have 100,000 users, so 100,000 users are basically disconnected at once. So they will be now they will be trying to, so all these 100,000 users, they will be basically trying to connect to other servers all at once. So this is a kind of thundering hard problem. So due to this, what can happen is basically a kind of sudden load can come on the all these servers, and it can actually have a sort of catastrophic effect on, basically domino kind, like effect on, all those servers. So in worst case, it can actually bring down the whole system.
Mhm.
So that's why we should not try to, disconnect all those servers or those users at once. So what we can do is basically we can actually give them some time. So let's say I give 60 minutes to, one server. Within the 60 minutes, what we will be doing is basically, within the first minute, we will basically ask some of the users to disconnect, and then within the second minute, we will basically ask the, next users to connect. I mean, there could be any other kind of strategy. The point here is basically we need to give them some time. So if we basically allow them to disconnect over a period of time, then this will basically probably not cause a thundering head problem.
But,
So
but
this can be one. Yeah, yeah,
but it can happen that one of your servers automatically crashed for some amount of memory error, let's say, or it hanged completely due to garbage collection or anything like that, that it is not responding at all, right? So
yeah,
in that case, all the users are gone, probably gone altogether at once. So you
yeah,
might not have control on this training, but what you might have control is like the users will be trying to join again, right, to the same server, let's say, right, or to tick a service at least to identify the next server to connect. So maybe you can control that by let the client having some random time, right, random time after which they want to connect. Let's say after immediate crashing, after 1 second, some of the clients are connecting. After 2 seconds, some of the clients are connecting. After 3 seconds, 4 seconds, some of the clients are connecting. Something like that, right? So all the clients
yeah,
should be configured in such a way that they connect next time to ticker service or to the previous server, whatever it is, but after some very random time, right? So you can generate a
yeah,
random time of say 30 seconds. Out of these 30 seconds, all of the clients will be choosing some time. So some client might be able to join after let's say 25 seconds also, just to distribute the whole load. So I think
yeah,
that way, even if you have new server, right? Uh, the ticker service will, I mean, the clients will be able to actually get back to the new server, but in a very distributed fashion, not all at the same time,
yeah. That makes sense. Yes.
right?
Yeah, that's a good.
So yeah, okay. So
Oh,
that can be done probably even by probably taking any server completely offline by ourselves, right?
yeah.
And okay, so yeah, so what about other things? I mean, that I understand that our portfolio order service is stateless also, right? So
Yeah.
deploying them or scaling them should be easy. Yeah. Uh,
Hmm.
okay. Okay. But is there anything to do for the databases? How do you make sure that we have enough copy of the data? Maybe we need to enable some backup, or maybe we need to have some replica or something like that for high availability purpose or for disaster recovery purpose. Would you like to talk about it?
So I mean, for Redis, I think we can make replicas, but I mean, Redis is basically not for the availability. So maybe we can ignore the availability part here. Uh,
I mean, you can have leader follower in Redis essentially. I'm assuming that this metadata is small enough to be fit in this instance,
mhm.
right? So we can have leader follower kind of things, topology for Redis. And actually, that should be fine in most of the cases. And it will keep the thing simple also.
Yeah, so I mean, the databases that we are using in our whole system are actually the relational ones only.
Mm.
So for relational ones, we can use a single leader and maybe two, three follower kind of system. So for each for each server, we'll have maybe two, three replicas. So that will also depend on the good number is basically to have at least two replicas if you are within the data within the same data center. Uh, but you should if you have multiple data centers, then those you should have some copies in those data centers as well. So I think it also depends on let's say if you want to scale your read load, then also you can increase the number of replicas here. So some of the reads can actually go to your read replicas rather than directing
So we
over
talked
the
so
zip.
we talked about partitioning the data by let's user ID for now for retail users. So
Yeah,
those partitions are also individual. I mean, I'm talking about physical partitions. So those are essentially distribute different machines. So all those
yeah.
machines have their own replicas. That's what you mean here, is it?
Yeah. They will also all of them will have their own replica. I mean, so what you can do is basically, let's say I have 5 machines. So and I need to maintain 2 replicas for all those machines. So what I mean, rather than having 20 different, I mean 20 more machines, so 2 machines per database. So we can actually, what we can do is basically we can put these two replicas in some of these servers. So let's say for partition one, my I mean let's say my partition ones, the leader is on, let's say, server 1. Then the followers can go to, one follower I can put on server 2, and the other
Hmm.
follower I can put on server 3. So this kind of system can be done as well. So
Yeah, I
yeah.
mean theoretically possible, but practically how much issues it will actually bring because if you just see leader follower, it's just a probably matter of configurations. You don't need to do anything out of the box. But if you want to do the thing that you are saying, it will need actually probably much more engineering here. I mean, you can make one machine as a follower of another machine, but again, you still have a lot of data to serve from this machine also, right? So that will actually add a pressure now that it has to serve as a follower to other machine and it has to serve as a leader for few other partitions. Whether it will be able to even do that. So that will require some another level of engineering effort, right? But I think just to keep it simple, we can have just a leader follower mechanism for all the partitions. And
Yeah.
since we are deploying this ourselves, so maybe we can have different data centers where followers will be available. So at least two
Mm.
data center, where at least one follower will be there in another data center. And maybe good old technique like backups, taking database backups, right, periodically should also help, just in case it is required or something, screwed up completely, right?
Yeah.
Okay. So anything you want to add on the reconciliation service? I mean, we talked about reconciliation of the payment file with the user transactions, but anything else that it has to do?
Uh, so we will have to see that, if our queries the reconciliation. So essentially, to make the reconciliation, what we do is basically we read some data, we analyze that data in a way,
Mhm.
and then we after analysis we basically identify that these were the transactions which don't look okay, something like that. So
Mhm.
essentially, basically, we are reading the data from the databases. So we'll have to see that how much time that query is taking, and how much pressure that query might be putting on the database. So if the queries are light, then it's okay to just directly run the queries on the databases. If the queries are heavy, then maybe it will be a better idea to take a snapshot of the database, let's say at the end of day, and then on that snapshot we run the query, and then we generate the response, and then we later delete that snapshot. Something like that can also be done. In theory, you can also read the data. You can put basically run your heavy queries on the read replicas, but the problem is if they are heavy, then the read lag I mean the lag will basically start increasing there. So I've seen in the companies that the lag can go up to hours. I've seen the lag of 16 hours as well. So
Mhm.
that actually causes some other kind of problems. So that's why, I mean, if it's heavy carry, then you better not run it on the reader replica. So you should rather take a snapshot before running your query. Uh,
Mm. But does taking snapshot actually take time or add some performance pressure?
I mean, yes. So snapshot is also not a very quick thing to do. So I know that we don't take the snapshot in heavy hours, so because it does put the pressure, but how much load it actually causes, I'm not really sure about that.
Hmm. What about creating views? I mean, usually views are created for read-only use cases, but definitely the view is present or the view exists in the same machine.
Yeah.
So the view just serves as a different table altogether, but for the same machine. So you whatever original table is there, that doesn't get the pressure of the traffic. Only the view actually gets the read traffic. But eventually the whole machine is pressured anyway. So as long as you traffic is, I mean, under the limit, then probably you can use view also.
So that also depends on what kind of query we are running actually. So if our, let's say, if somehow we could create a view, uh, I mean, on which the query actually runs very fast, rather than running the query on the actual data, then maybe we can use the view as well. For example, let's say we do accumulation queries. So let's say if we have to just you know create add maybe all the account balances in a particular time range. So maybe those kind of things actually can be better done by the view rather than running the
Hmm.
query on the database.
Okay. I think one thing that we missed out here is the reporting thing, right? So let's say you want to download report of your stocks or portfolio or for some financial year, for some months and whatnot. So if I add this requirement here, right? So how will you actually do this?
So who wants to download these reports? You mean users?
Yeah, like users like us, right? Or institutions who will be able to download.
So let's say if a user wants to download their reports, and so what we are essentially going to do is basically we are going to read all the orders from the order database, and then maybe do some processing, and then we generate the report.
Yeah, I
So
mean you can scan the order database definitely, but do you want to scan it for long range all the time, or you want to actually pre-compute the data every night, something like that, right? I think one option can be like pre-computing the orders every night, and only for today serve it from the order DB.
yeah, one more thing that people do is basically they put this data in Hadoop or something like that. Then
Hmm.
whatever the heavy queries are, basically they will be run on the Hadoop. So Hadoop is actually more scalable in that sense. So
But it makes more sense for big tech. Basically, it makes more sense
yeah,
for huge amount of
yeah,
petabyte scale of data. I don't think so we'll have petabyte scale of data here yet. So I think as
yeah,
long as
maybe in
you
years.
can probably add a reporting table here, right? Which will eventually look like order table only, more or less. Uh, but yeah, I mean, like whole portfolio, not order table. Sorry, the portfolio basically portfolio table, right? That this is a portfolio value or something like that, or maybe some aggregations will be there, right? So you can build it
Yeah.
every night. Yeah. Okay. So just to conclude, uh, would you like to add the DB schema for portfolio table, order table, just like we added for wallet?
So portfolio, it would look. Let's say this is my portfolio. The schema would look like we should have some primary key. So let's say this is my portfolio ID, and then we have the user ID. Then
You will have symbol.
symbol.
Yeah.
So we are basically
Yeah.
going to create one row for each symbol. I think that will be
Yeah.
better.
Yeah. Yeah, I mean, it will be keep on, it will be on update every time you add the same stock. Probably it will be updated, right? So I think
Yeah,
not only symbol is enough. I think after symbol you can add things like what was the value at which the symbol was bought. So you can just add it. Uh, something like buy value,
yeah,
right? So maybe uh, yeah. So here basically something like buy ticker basically, buy ticker well, right? Then quantity that you bought, uh, then amount, a total, what amount you have actually invested, right? So that will your portfolio look like most likely. And the current ticker value will definitely be served from the S1 S2 servers.
yeah.
And and yeah, in a similar way, you can actually create for orders also. Yeah. So order will also I think look pretty much same. Just that order is nothing but some. I mean, if you put for a single ticker, let's say you have ordered 100 first, and then after 5 minutes you have put order for the same ticker, but for 1000. So there will be two entries instead of one entry. So I think portfolio will keep on updated, will be updated all the time you add something to the portfolio or sell something to the from the portfolio. It's just the current
Yeah.
snapshot of the data, but your order database will have in a similar schema, but it will have every transaction recorded, kind of a ledger,
Yeah.
and maybe some internal status that what was the status of the order, was it actually settled, or was it actually discarded by the exchange or anything like that. So order state will also be there, right? So yeah, so something similar with some state. Okay, so order ID, OID, user symbol, buy ticket value, quantity, amount created at, and maybe status, right? So something similar will be there. Yeah. Anything you want to add here?
So in watch list, I've basically, according to this schema, let's say if I have 10 stocks in my watch list, then there will be 10 entries created. So we actually don't need to do that. So we can just put all the list of symbols here as well. Because the thing is, the watch list actually, what we can do is basically from the client side, we can just update the whole watch list at once as well. And I don't think we will be basically doing any searching on this watch list, that which symbol appears in which users watch list, those kind of queries we want to be running. So that's why we can also take this approach. So
Yeah,
this
I
will
think watch
actually save.
list watch list
Yeah,
can be served. Yeah, watch list. Do we have watch list DB? I think watch list can be directly served from Redis itself. DB can be there. Yeah, DB can be there just as a source of truth in case the Redis cache goes down, right? Yeah. But I think watch list will be anyway served from the Redis cache all the time, even for the read queries to actually identify, which symbols the user has actually subscribed to. Yeah. Yeah. Yeah, I think it makes sense. Or I mean, in a proper relational sense, you don't add list of symbol, you add one row for each symbol basically, right? And then you just aggregate it. Yeah. Okay, man. Anything else? I mean, we have APIs and stuff like that, but I think those things we can leave for now, right?
yeah.
Uh, we are not going in depth of the API request response schema. That will be like very uh, another low level detail. So anything else you want to cover here regarding deployment or anything like that, or anything else you want to add here?
I think I'm good. Nothing else to be to add here.
Mm. Okay, I think this has been too long of a video also. Right, but I think it was actually very good discussion, very productive, very satisfactory discussion because we actually touched upon many different flows and many different parts. So let the viewers actually come back and put their feedback, and let's see how they perceive it. Yeah. So thanks for your time, Karthik. We'll
Yeah.
we'll collaborate next time for something else. Yeah.
Yeah.
So let me stop the recording. Yeah.
Thank you.